Excellent. Huzzah! Hello. Hi, Pyrex. Indeed, indeed. Let's see, you can hear me. I can see you. I got chat doing chat-like things. We'll see that on mobile. Yes. Excellent. Alright, good. Alrighty. We're doing more stuff. Tonight is gonna be a creative day. This is the third creative day in the 30 days lost in space. And looking at this, looks like there's gonna be probably one more before the entire exercise is completed. But this one I figured it's probably gonna take up the entirety of the stream because I have an idea of what I want to do. I don't know if it's going to work, but that's what we're here to find out. I'm gonna play the little intro video that they gave us, and then we're just gonna jump into it.
Welcome to day 15, the third creative day. First of all, I want to give you guys a round of applause on making it halfway through the course. Yes, you guys are 50% of the way through the 30 days Lost in Space Adventure Kit. Congratulations on making it halfway. You've got only, well, 50% more to go. I've decided to mix today's creative day up a bit. Normally, I would give an easy and a hard example or hard project, but today I'm going to go back to the lesson from day 14. I have a wonderful project for you guys to work on. Do you remember the bool validate pin function from yesterday on day 14?
Yes, I remember the bool.
Currently, there's a small security flaw with it. As soon as an incorrect button is pressed, it will exit the function and return an error. Well, that makes it really easy now to guess which of the numbers that was pressed or which part of the pin is wrong. So you just can guess 1 through 9 until it goes through to the second pin, and then you can know, okay, so the first pin is, in this case, 4, or whatever you want it to be. And then the second pin is up, error, up, error, up, error. Oh, the second pin's 6. Well, that's easy now. So it makes it really easy to brute force. That makes it a pretty insecure system, even though we've added in this additional security system. So what we want to make it do is instead, we should make it so it doesn't print an error until all 4 numbers are typed in, so they don't know which number was bad. Of course, you're also open to do your own project if you so desire. That is totally, absolutely always on the table.
Naturally.
Once you're done, share on inventor.io/Facebook with the hashtag CreativeDay15. I am once again looking forward to seeing what you come up with, and if you run into any issues, hit up your fellow inventors in the Facebook group at inventor.io/Facebook. Thank you guys.
Very Facebook shaped. Much wow. Actually loud music, hello. Yeah, so that is what they gave me, which, as you can imagine, is a creative day. There's no code, right? But that's okay, because we're gonna build off of day 14. I do want to make it not show the error and just accept all 4. I have the thought of how that's going to be doable in my brain. We'll try to get that in the code. But the other thing I wanted to do, I'm changing 2 things around in this. In day 14, we were given the RGB LED. I'm taking the RGB LED out. I'm replacing it with 2 individual single color LEDs, and we're gonna have the big button, which I'll get to that. Two wrong guesses, release the hounds, but I guess we could fix it either way. Yeah, that's funny. I generally don't look too far ahead into this. like I might just like complete the day on here, but I try to go into this mostly blind, but with the creative days I looked at this one just to see what they were gonna propose so that I could see what I wanted to do. But let me show you what I've pre-wired a little bit of this because I have a funny feeling that well, I changed a little bit of wiring. Let me show you. I want that. Okay, there we go. I don't know why the microphone wasn't selected. That's better. You can hear me now. Good. I looked in the scene and I didn't see anything moving, which generally indicates I've got a problem. Oh, hang on, let me turn on the lights here. Okay, that's better. Oh yeah, get this on. All right, good. All right. I got a couple of things that we're doing here. First things first, we've got my comically large red button. This very lovely item is a simple push. It doesn't latch, so if you press it and you release it, it just goes back into the position it was in. So this is referred to as a momentary switch. But who doesn't want to do that, right? Like, smack the button, activate the defenses. I'm being goofy. I am aware. This is all very good. Yes. So that it's gonna be difficult to pick this up. Haha. And then we have the LEDs that I switched out. So I purposely switched out the multicolored one for 2 just basic LEDs because I needed an extra input on the Arduino board. Because right now we have the keyboard hooked up, which is taking up 8 wires on the digital pins. And then the LEDs, I'm gonna have to write these down on which ports I plug them into, are taking up 2 more. And then for the button, I only needed 1 more pin. And I didn't know if I could hook up a button and read back its state on one of the analog pins that I have on this side of the board, down here. So I figured, switch this out for 2 different colors. It's easy enough to figure out if we're gonna be in pin accepting mode or if you've been successful or denied. I'm thinking that for deny, we let up red. That seems pretty straightforward. And then if we're accepted, we let up green. Also seems pretty straightforward. But the mode that we would normally use for displaying we're in programming mode, I figured just put on both LEDs at once. That should be pretty easy to figure out with the visual representation of that. But the, let me grab my sticky notes here. I need to write down which pins I plug those things into. Yes, this, yeah, pin. Because everything else, wiring-wise, I kept exactly the same. The buzzer's still in the same place. It's still in the same pins. That didn't move. But I did move LEDs. Because the RGB LED takes up 3 pins, and then the 4th one is the ground. So there's technically 4 wires coming out of it, and 3 of them have to be hooked up to the Arduino to control it. So I needed to get 1 back. So this is what we did. So let us take a look here. Because once I have these written down, then I have an idea of where we're going from here. Let me put the big old honking button right there. Let me get a good look at this. Okay, so from my layman's perspective, partially off camera, I've got my red LED is hooked up to pin number 9, 10, 11, and pin 11. The green one is on pin 10. Is green, and then the button we have hooked up on pin number 9. 9 is the button. Okay, then the speaker I kept in the same place, so the code doesn't have to be adjusted or updated. That's on pin 12. Suppose for my own reference, I'll write that down. Which, am I correct on that? No, wait, which 8, 9, 10, 11, 12. 12 is the buzzer. Okay, and then the keyboard I kept all in exactly the same place, so I'm not going to bother writing those down. So, I got my notes. Let's see what we can do with it. Thank you for putting that in chat. I appreciate it. Okay. Now, I didn't clear the code out of the previous exercise, so we might see some strangeness here when I plug this into the computer, but I don't see it to be an issue. We'll get the exercise open, and then we'll get the board programmed. Wouldn't be surprised if we were to get a rogue flash over here. Now, the way I have the button hooked up is the same way that we hooked up the dip switches. That was the little red pack of switches from, I want to say it was day like, maybe 3 or 4. It was really early on in the exercise, which I'm a little surprised that these didn't kind of make a bit of a comeback. That were these little guys. Dip switches, dual inline package is what they stand for. And you have these little switches you could turn either on or off. Well, I figured, why not make it fun and make it a big button, right? This is just a comically larger version of this. Except these hold position. This is momentary. Probably shouldn't press that since I haven't programmed the board. Yeah, it's fine. I'm not gonna bother anything. At least I don't think I will. Okay. Alright, give me a moment while I get up the exercise, because I forgot to do that. Okay, I was working on a different project here that is not related, so I can close that. And then off camera here, I'm just going to duplicate day 14. I just have to go find it. So we're gonna have day 15 and rename and day 15, and then I'm gonna open up technically day 14, but I've renamed it to 15. Okay, close that out, and then I'll show y'all exactly the same code that was presented in the previous day, and this is what we're going to tinker with. So this is kind of my thought process. I want to get it working so that we can get those two LEDs working to just fill in the blanks where I took out the multicolored one. That should be pretty easy. We're just going to declare those pins and then just use pretty much the same code and just shove in there the appropriately colored LED to then get our statuses. The second thing that I know that's probably going to be a little bit more difficult, but I still think it's going to be doable, is putting in a system lockout. That's what the big red button's going to be for. When we hit the big red button, the idea is that it's going to make the system beep at us, flash the LEDs, and lock out the keypad for, we'll say like 10 seconds or something, right? To give us a panic to exit the system. Now, all the code is compiled and run at runtime, as the name would imply. So I'm not necessarily sure if we have a way that we can write this that would allow us to be able to break out of the loop, because the loop is infinite, right? So realistically speaking, the big old panic button I think will only work when we're at the beginning of the loop. Like we've just loaded up the program and then you have the option to choose what to do from there. So if you're caught in the middle of a pin reset or actually entering the pin, yeah, if you're at any point capturing input, I don't think there will be a way to break out of that with the big old button. We might be able to, I don't know, we'll have to see. I'm under the impression of no, at least by what I know. And then if we have time, I don't necessarily know if we will or how long this will necessarily go. I want to see how difficult it will be to try to write this pin into the EEPROM, which is a storage that uses to hold the program. Because if you remember from the previous days, if I power cycle the board, it forgets the pin we set because it was just in the running memory. When power is gone, running memory gets flushed because it's volatile, and then it reloads the EEPROM, which is the program that's non-volatile storage or permanent, and then we start over. I have a couple tabs open on the laptop here that we'll look at. Maybe if we have time. I would like to try to hold that value. If not, I might cycle back around to it at a later date, depending on how difficult it is. So let's get started. First things first, we'll do the easy stuff. I know the LEDs are not that hard to figure out, so let's start there. Red LED's on 11, green's on 10. So first thing we're gonna do is we're going to locate the declaration for the multicolored LED. So let's see here. So this is our keypad. Thankfully, we don't have to touch anything with the keypad. It's plugged in exactly the same place. So these multi-dimensional arrays, I don't have to touch. I don't want to touch them. They look pretty fancy all by themselves. I probably should switch scenes. I want to go back over to this one. Haha, okay, good. That's better. You can see things now. Okay. Yes, so I don't have to touch any of the code for the keypad. I'm gonna leave it alone. I'm not gonna look at it. Now, I should be able to see right here a couple of things. So there's our constant for the buzzer. My eyes did not deceive me. I wrote down 12 for the buzzer, and that's still true. And then green, I hooked up on 10. Now here's something that's funny. Green is already 10. That was for the multicolored LED. And then red was 11. I can swear to you, I did not do that on purpose. Blue is on 9, and 9 is going to become our button. And that's hysterical because I don't even have to change the declaration because I wired them in the same place that they would have existed in the multicolored package. They're just individual. Okay, cool. The LEDs are done. I didn't have to do anything. Yeah, that's what we're talking about right there. That's saving time. Oh my word. Okay. All right, blue pin we're going to rename because it's not a pin, all right? So this, well, it is a pin. It's just not a LED-shaped pin. It's a big honking red button. So this is going to be renamed to the button pin. Okay, so that's going to be the button pin. It is technically still a PWM pin, so that's not wrong, but I'm going to update the comment. To read the button status. Now, the next thing we need to do is change our pin mode for the button, because the button is not an output. The button is an input. We are waiting to see if something has happened by reading the value of the button. So I have to switch this from output to input because we're trying to read something. Okay. Now, we no longer need the function for display color because we're no longer working with a multicolored LED package. So what we're going to do is we're going to scoot on down to the display color function and eat it. Goodbye. I don't need it. I can leave that comment there. We'll need that. We'll need that. I will have to change out all this stuff for the declaration of display color. Because right now I removed the function. If I were to compile this, I'm going to get a ton of red on the screen. So all we're going to do is we're just going to update the code to indicate the different colors that we would like. So the first thing we need to do is we initially wanted a red color. And what I'm going to do is I'm going to go open up, I think it was day 6 that we started to look at the LEDs. Yep, so we can see here that low and high, I'm just going to copy that code out of there. So something I can tell you right now I do very commonly. Once I worked myself through an example, I am totally down for just reopening it to grab out what I need. I have no reason to refigure this all out again. When I already have an example, I understood it. I may just not know the syntax off the top of my head. I do it all the time. There's no reason to have to refigure it out, which you're going to see a lot of that this evening, because we have a bunch of building blocks here and we're going to work with them. So first things first, I'm going to get rid of that. And then I want to turn on a red color, right? That was what the code was doing. So we are going to turn on the red pin. So we're going to turn on the red pin. And then I don't need the delay that I copied over. I know how to do that, so that's fine. And then I don't want to immediately shut it off. So this I am going to take out of there. Actually, here's what I'm going to do with it. Since I'm going to need both of these more than once, I'm going to leave a commented version of them up top that I could just copy again. So up here above the void, I'm just going to leave myself a nice set of commented out chunks of code. I know, Cyberblaze, right? Welcome in, welcome in. It has been a whole week. And I can't tell you guys how fast Wednesday comes anymore, because this I look forward to, but obviously you can tell that part. But the fact that it comes so fast, the middle of the week is just a snap, and it's here. It's kind of nuts. Okay, I don't need to turn that immediately back off, so I'm gonna get rid of that. All right, so top of the code, we are locked out, right? So we want the red color, so we turn on the red pin. We then start the serial monitor, we press the star to set a new password, or pound to access the system. We are going to modify this a little bit, but for right now, we're just going to leave it. We're not ready to mess with that just yet. All right, this I'm going to copy and I'll bring you along with me. And then let's see here. So if the button character is the pound symbol, we want to access the system. Okay. Let's see. So we are waiting to get the key input, to which then if it's pound, We then go into the give input feedback function. So let's go down to that. Give input feedback. Wait, I think I misread that. Give input feedback. Okay, that is what it was. Here it is. Okay, so the give normal feedback is a short beep, and it says a blue LED. Oh, sorry, that's a call for it. Gotta keep going. Here we are. Okay, so we obviously don't have the blue LED, right? I only have 2 LEDs. So we're in the process of giving feedback to the screen. I think what we're going to do is, instead of doing one color, oh, I stole this from, hang on, let me undo that. Oh, this is the code that would turn off the red LED briefly. Turn off LED while playing the tone. And then, see, now this says restore the blue LED for giving input feedback. But up top, I don't think I ended up pulling that. Oh. That's fair, Blaze. I understand, Sleepy Eepy. Yeah, I do remember it mentioning here that when you are working with the buzzer, that when it gives off a sound, it would cause the light to flicker briefly. So by just turning off the LED will prevent the flicker. So I think what we're going to do is, even though, because this is a function, right? That means we can call this multiple times. We're going to write this so that it just turns off both LEDs. So there's no illumination when we call the give input feedback. So I'm going to do this to a low for the red and for the green. So if at any point hey Pyro, all right, tone buzzer, boop boop, delay 2 seconds, and then it says restore blue LED, and that was give input feedback, right? So if we look at the beginning of the code up here, after we've clicked pound, we give input feedback. And then access allowed is equal to validate pin. All right, so if we go to validate pin, this is the other function we're gonna have to mess with. I just want to see what colors are in here. Okay, nothing. There are no colors in the validate pin function. Declared individually. There might be within the functions it calls, but right, and this is indicating to return to blue. Now input feedback, and you know, I'm just gonna nix the idea of an additional color. So when we give the input feedback, it's just gonna turn off the LEDs. We're not gonna get anything. Oh, I scrolled up too far. I apologize, there is going to be a lot of scrolling up and down because the code causes us to have to jump around because of the way it's written. But that's okay. All right, so the light's going to be red when we first turn on. We then go to enter the keypad. Input feedback is going to turn off both LEDs if either of them are on, which the red one will be. So it's going to shut them off, play the sound, and then wait. It's going to jump into validate pin. So let's go take a look at that next. All right, so here's validate pin. Up to the monitor, the serial monitor, it says enter a pin value to continue. So this loop says for int I is equal to 0, I less than pin length, I plus plus. Now we know up top the pin length is declared as 4 individual digits. And that's fine. We can work with that. We wait for the button input at the top of the loop, and then if the password in the position we enter it is not equal to the button character, this is the part we have to change. Is give error feedback, which plays the angry sound, and then on a new line it says wrong input digit, and then the actual digit we got wrong. So I can tell you right now, we're not doing that anymore. I don't want them to know that they put in an incorrect digit or what it was. That does not need to be there. We still need to be able to return true or false. But what we want... we want to know if a problem occurs. And then if the problem occurred, then return false. So I think what we're going to do is we're going to create an additional variable inside of the validate loop, where we're simply going to set whether there was an incorrect pin, or an incorrect number in the pin, and it's either going to be true or false. So if the problem comes back true, the function will return false, because false means that the pin was incorrect. That's the way it's written right now. Otherwise, that function gets to return 0 for true, to which then it'll return the function of true. So then if at any point during the button press of those 4 sequences, I don't have to change the logic the way that it's written. I'm just adding something additional, and there's going to be one more if statement we're going to add to this. I think that's the way we're going to handle this. So other thing we want to get rid of here is this other serial, and the give error feedback. I don't want this in here. Well, I don't want it there anyway. I want this to return true or false depending on an if statement at the very bottom. So we're going to have to move some of this around. But that should be okay. So for right now, we're going to say that we have a I want a Boolean type variable, which I know that up here we have bool access allowed. And booleans are either going to be true or false. So what we need to do is before the loop, right? So validate pin. I want to make the variable and set it, and then the loop will dictate on what the value changes to if it does at all. So I want to say bool PLEM problem check is going to be equal to a 0. So in my mind, I may have the logic backwards, but we're going to check here in a minute. Well, for a second there, I thought you got auto-modded. I don't know what Twitch did to my overlay. Okay, cool. Welcome on in. Yeah, we're here. We're tinkering. We're tinkering. Oh yeah. Oh god, Unity. Both you. All the 3D rendering space is ridiculous. 0 is. Actually, no, 0 would technically be false, wouldn't it? I want to manually set a boolean inside of our compiler here. So let me see what the internet says is the correct way. Maybe I should just use the words true or false. I don't know what the compiler will take though. That's not what I wanted. I want... Oh, it's literally the word true. Okay, so here's what we're gonna do. So we're gonna do... I'm not gonna make this more difficult than it needs to be. I'm already pretty bad. You know, instead of saying problem, let me think about this for a minute. If I call the variable problem check, that doesn't necessarily indicate of whether there's a problem or not. True wouldn't really mean anything to us, right? So let's say instead of problem check, let's just call it problem, right? And let's set it to false to start with. Here's my reasoning behind that. You want to give your variables meaningful names so that you, future you, has an idea of exactly what that code was supposed to mean, right? I could call the variable anything I want, but if I give it a name that I don't quite understand immediately what it's for, that's a problem. Because if I can't immediately identify it, then that means my comments need to save me. And I don't want to make this more difficult than it needs to be, especially for myself or anybody else who's watching. So we're just going to call it problem, right? And right now there's not a problem, so false. There is no problem, right? So if there is no issue with the pin, return false. Otherwise, return true for a bad pin. Olby, you didn't do anything. My overlays disagreed. You're fine. No worries. Howdy, Porsche. Okay, so we have our problem, and our problem is set to false, because currently there isn't one, right? Now, we're going to hop into here, and if the password at any point is incorrect, we are going to set our problem equal to true. So that means there's an issue. But we don't want to immediately alert the user there is a problem with the pin, because the whole idea is so that they don't know what particular number caused the problem. So this loop is going to run a total of 4 times to get the pin. And then after that happens, we're not going to return false here. Our returns we're going to move around, so I'm actually just going to delete that altogether. And we're going to shorten up that if statement. So during the check, if there's a problem, the problem is true. There is now a problem with the pin. We don't want to return true because there's a problem, right? So down here, give input feedback. Let's go see what that does. Give input feedback. give input feedback. Oh, it's right here. Okay, so input feedback just keeps the LEDs off and makes the sound. See, this is where we reuse that code again. And that's fine. So we're just going to hear a beep. The LEDs will do nothing. To which then, whether it was the wrong or right, it will actually print the star on the screen like it says here. It's going to make the beep, print the star, and then at the bottom here, we're going to add an additional if statement, and then we're going to change some stuff around here. So we're going to say, aha, I see a wave from a pine sap. Hello. If the problem, because aren't we all, is equal to false, like it's spelled, false. If there is no problem, then we are true, right? So we're going to return true. Otherwise, we're false. Let me rephrase that. This is where things get a little confusing. If there's no problem, that's false, which means we return true. The pin is correct. Otherwise, if problem is true, right, there's only two states that this can exist in. So the else statement is just, if it's not false, then it's true. I know I'm writing this backwards, but I'm doing this because logically speaking, you would want the correct answer to be on top and then the incorrect to be on bottom, at least in my own mind. I could write this either way. It's just what makes the most logical sense to me. I want the success to be on the top and then the failure to be directly below it. But we still have to capture it either way. Now, this line that I didn't delete earlier, the give error feedback, we're going to run off with that. And we're going to stick that down here. And then I could spell. There we go. Okay. Let me save that. I've been typing here for a while. So we run through the 4 full cycles. Now what's important that I just thought about here is that this is inside. Is this inside of the loop or is this outside of it? Where's that loop? I want this outside of the loop. Okay, there we go. The loop ends right here. Loop ends here. Okay, good. Because I can't have that in the loop because I need this to happen after we're done getting all 4 numbers. Because this is what we're going to return back to the user. If there was no problem, problem is false, we give the successful feedback and the successful LED, which we have to adjust, and then say that the device is successfully unlocked. Otherwise, then we're going to give the error feedback sound and light, which we should be able to adjust, and a return false. And then the code will be able to continue from there. So let's go take a look at the give success feedback. Okay, so our success feedback, we're going to do the same thing. We're going to turn off. In this case, they're already off. But this will just reinforce that idea. We play the buzzer, of the happy successful sound, and then we are going to turn on the green pin because we successfully accessed the system. So instead of a display color function, we're going to use digital write, and the green pin is going to go high. Ergo, turn it on, which then tells us that we have successfully accessed the system with the little happy tune. And then the error feedback, we can also adjust while we're down here. We will again keep the LEDs off during the buzzer sound. And it's quick, so it's going to play 2 tones. It's like a burp burp. It'll delay, and then I want to turn on the red LED. Okay. So now let me double check our work and validate pin. All right, so we capture the pin. We set our initial value of problem equal to false because there isn't one. We enter the loop, we capture the first button press, we store it, and then if it's not equal to the button character that we're pulling from our running memory, we then set the problem equal to true because we have an incorrect button press. We then continue onwards, informing no one, and we call give input, which just makes a sound. There is no blue LED, so I'm going to just omit that. Just say short beep, because that's still happening. We print the character on the screen of the star, not showing the user what they typed, but simply that the fact that the input was accepted. So they hear the sound, we see the symbol. That runs 4 times, because it's based on the pin length that we set further up in the code, which is 4 individual digits. From there, we then determine what we're going to return back to the user. So then we see here, hi Mountain Man, hello. We see here that if there's no problem, then we give the success feedback sound with the green LED and the ta-da, which we did change the code for. We then say the device is unlocked, return true, and the code is now finished. Otherwise, there was a problem, so then we give the error feedback, which will do the error sound and illuminate our red LED. To which then we return false to the function. So now we have to pick back up where we left off up here. Which was right here. So now validate pin runs, we either get a true or false here, to which then we get, if it's true, welcome authorized user, otherwise access denied, and it reprints the line on a new line to either choose star or pound, and we're back to the main loop again. Otherwise, if they click the star symbol, that puts us into new pin entering mode. So let's see here now. If they do that, we give the input feedback, which is the short beep. There is no blue light because I omitted that. That's gone now. We then run the same function that we just worked on to capture the pin. It will return true or false. And then if they got it right, this was to display a yellow color. Now we no longer have yellow because I only have red and green. So what we're going to do here is we're going to just turn on both of those LEDs when we're in programming mode. So I'm going to grab both of these and we're going to substitute it. So we're going to say right here, one too many. Okay, so we're going to turn on the red pin and the green pin. Not green built in, I want green underscore pin. And I want that on. And then I'm gonna, since this is relating to both of them, I'm just gonna put it above it. Display red and green LED while entering a new pin, indicating that we are in pin changing mode. From there, we will then welcome the authorized user because we verified their pin being valid, enter the new pin. From there then, we then run through the process of capturing the new pin. So let's see if we have to make any changes to this. So we're going to look at our password. We're going to capture it. We're going to give input feedback, which is just going to be a sound. And then there is a color override here during the programming, which would have given us a mix of... Oh, that's right, because give input feedback is going to clear it. So we're actually just going to bring both of these down for this color override. Because otherwise we'll end up losing the colors that we turned on. And I don't want to do that. I want us to stay for that to stay on during the entire process. Which then it'll play this, it turns off the LEDs because give input feedback does the buzzer, turns off the lights, this turns them back on. We print the star to the screen, and then after that, we add a new line all by itself and say the pin was successfully changed. Do yourself a favor, don't type it wrong, because then you're not getting back in. We then give the successful feedback. Otherwise, if you entered the incorrect pin in that function for verifying returned false, we tell them that they're denied. You can't change the pin without knowing the current one. And then it takes us back to our how to access the system or change the pin again. That exits the main loop. So everything down here, validate pin, we did. We have input feedback, success feedback, and error feedback. So I'm going to try to verify this now, and we're going to see if I missed anything. I forgot to connect the board. Hold on a moment. Let's see here. That was the mini. Or if I can get away with just telling what board it's on. Fully qualified board name. No, it's called a hero board, but I think it was using the Uno's name, I think. Wow, I'm pretty impressed with myself. I didn't manage to miss a semicolon or miss clearing a declaration. Lovely. So, with that, we're going to take a pause and we're going to check and see if the code that I've written so far works as intended. I don't want to go too far without checking the wireframe of what I've changed. Because if I keep going and never test the stuff, because I just changed a whole bunch here. I changed 3 different functions in the main loop. because I gutted out what we didn't want to use and added what we wanted to. So I'm going to program the board, and then we're going to check and see if it behaves as expected. Because right now, nothing is lit up. So I'm going to upload. And if I wired everything correctly, we then also have to turn on the serial monitor to see what we're doing. Okay. So first impressions. We have start, enter new password, or pound to access the system. Now at the beginning of the loop, I told it to turn on, I'm pretty sure they have red LED. Let's see if that's actually the case. We have red pin, turn on the LED. And that's during the setup. Which is pin number 11. It's an output, and I don't see it lit up right now. So let me check and see if I forgot to wire something up. So I definitely think I messed something up here. I see this center LED on, which means I messed up one of the declarations. The built-in LED, I copied code to control that, and I'm pretty sure I missed something here. So let's take a look at our code and see what I forgot to pull out. Because I pulled over this example, LED built in, I should have just changed this in here because I copied it. It's going to change it now. In case I need to nab it again, which I don't think I'll need to, but you know what? Doesn't hurt. Alright, so digital write red pin. And up here it is declared on pin number 11. I'm just going to revalidate that. And then I'm also going to take a look for that built-in LED, because I feel like I probably missed something here. We enter the main loop and we wait, so that color should have changed. I must not have something wired on the board correctly then. Yeah. We have that. Red, green. Red, green, red, green, red pin. Okay, so I'm not entirely sure what's going on there, so we're just going to take a look at the actual board and see what I'm missing. Must be actually something physically wired that I messed up. But that's okay, because it's part of the learning process. Let's see here, we've got our ground connected to ground. You know what we don't have hooked up? I don't have 5 volts hooked up to anything. So there's no power going into the board. Yeah, that's kind of important. Otherwise nothing's going to work. Because I have the rails jumped together here. Wait, no I don't. What do I have jumped together here? I've got positive to positive, negative, not to negative. All right, I missed 2. I missed a couple things here. All right, first things first, I need both of these connected together, otherwise nothing's going to happen here. I need the negative and negative of both sides of the board hooked up. So I got red here, which is that negative, and then I want a probe that has a male end on it. Yeah, that one will work. Yeah, this one will work. Okay, so then I want... Oop! Breaking my own rules. Temporarily gonna disconnect the board so I don't actually fry anything. The positive to positive. And then positive to 5 volts. Because otherwise nothing's going to happen. Which if I look here, it's going to be VIN, ground, 5 volt. VIN, ground, 5 volt. Which is right there. Okay, so yeah, I did not connect the 5 volts to the board. That's why nothing happened over here. So there should be nothing wrong with the code, and when I hook that back up, we should get red now on that LED when the code initializes. Maybe. Unless I mess something else up. Well, I'm not seeing anything, so that's not necessarily good. I do have the grounds hooked up to ground. I got the grounding rails connected. Did I ground the rail? That's the next thing we gotta check. There might be no path to ground. I've got ground to there, and the ground on here goes where? Goes to the end. Down here. Okay. I did ground it. I added 5 volts into it. And then what did I mess up? I wonder if there's a chance I plugged the LEDs in backwards. Which, I suppose there's a chance. Let me take a closer look at this. Apologies while I check this off camera here, because I need to get it a little closer so I could see it. Alright, so I've got 5 to 5, ground to ground, 5 to 5, ground to ground, then that ground goes to ground on the speaker, positive on the speaker goes to pin 12. I have 2 LEDs, go from the grounding rail through 220 ohm resistors, which then talk back on pins 9 and 10, 11 of the breadboard to lead back to 11 and 10. And then the button is on 9. And that does go to a, I think that's 1 kilo ohm, 1000 ohm resistor back to ground so that we don't have any floatingness going on there. LEDs don't look burnt out. These are hooked up as intended. And the button does also look connected as intended. Let me interact with the keypad and see if this gives us any blinkage or sound. Alright, so we got sound. Enter pin to continue. Be able to do. Alright, so I entered 4 zeros, which is the default PIN. And it says here that the device is successfully unlocked, so the code is functioning in that capacity. Let me call the thing to change the code, which was this one. Enter pin to continue, 4 zeros. And then enter a new pin. I'll just keep it the same for right now. Pin successfully changed. And then it's pound to go into the system. We're getting no feedback from the LEDs whatsoever. Alrighty then. disconnect it from power. And I'm gonna pull it out. And we're gonna check. So I'm getting 5 volts from the left side of this connection and then going towards ground. Now, if I remember correctly, a 5 volt LED, the longer leg should be the one that is the ground path. Double check that. Let's see, LED. Legs of the LED usually have different lengths. Longer leg is the positive, while the shorter one is the negative. I installed the LEDs backwards. Yep, that'll do it. The longer leg is the positive. Okay. Well, I'll definitely explain why I'm not getting anything, because I put it in backwards. It's kind of hard to tell because they're a little bent, but this one on my left side is longer. So I have to install this with the longer leg to my left. And then longer leg of the green one that way. Okay. Now, LEDs are also a type of diode, so the voltage being as low as it is, I can't actually do any harm of installing these backwards, because a diode resists the flow of electricity. If it was an exceptionally bad time, then, or excuse me, exceptionally large voltage, then yeah, I absolutely could have fried them. But since a diode will work, it just resists the flow of electricity, you get no brightness from an LED if it's installed backwards, like I did. All right, so I'm going to put in the correct password quickly, just to make sure the green LED lights up. Which is going to be enter the system. Now, like I said, entering the system turns off the LEDs, and then we're going to put in the pin. I'm successful, and the green LED came on. Awesome. All right, so that was easy enough to fix. I had the components backwards. We're going to go back into programming mode. So we're going to do the star symbol, and then we're enter the current pin, 1, 2, 3, 4. And now we're in programming mode. Okay, code is working. We got 2 LEDs on now, red and green. Then we're going to put in the new pin. I'm going to make it 1, 2, 3, letter A. Pin says it successfully changed, and it went green. Right, because in our code for accessing the system, it accepts it but it unlocks it, because it does pass that we've successfully got into the system even though we changed the pin. So I can click pound to log back in and check to make sure it held it. 1, 2, 3, letter A, and I'm successful. Okay, let me show that from the terminal view. I want to go back to this one, and I'm going to move my head out of the way. Okay, there we go. Okay, so I'm going to clear the terminal first, hang on, with that button. And now I'm going to show you in the terminal what I was up to. So, you saw the LEDs, right? In the code, this part stayed the same, right? So, if I restart the board by just uploading the code a second time, bloop. Okay, so right now I've got the red LED turned on the board, and I'm going to click the pound symbol to enter the system, and then I'm going to enter the correct pin of 1, 2, 3, letter A. Oh, that's right. I reset the code. Hey, you know what we just tested? I put in the wrong pin and it went into the last digit before it barked at me. So that works too. We needed to test that use case. I was going to do that next, but turns out we're doing it now. All right, correct pin. 4 zeros. 1, 2, 3, 4. Okay. Device successfully unlocked. And then let me put in another random 4-digit pin. 1, 2, 3. And that was incorrect. So it access denied us, and then it's to the terminal, and our LED is still red. We have not gained access to the system. So the first half on all of this was getting the 2 LEDs working, which we did. And we've got... Oh, thank you, Blaze. Enjoy your steeps. We got our LEDs working. They're hooked up correctly. That leaves us with 2 things. The big honking button, and we're going to see if we could dabble with storing that pin. Because you saw when I power recycled it by sending the code a second time, it flushed out my pin. Now, obviously, reprogramming the board will erase your pin from memory. That's going to happen. I'm not worried about that. What I'm worried about is if this board were to lose power. Say you were running this board as your pretty basic door controller or lock controller, and the power went out. Well, power comes back on. You want to read what your pin was from the memory. We're going to see if we could do it. I don't know how hard it's going to be, but we're going to try. Before we do that, though, I want to program the button. Right now the button didn't do anything, so I could click the big red button and nothing happens. Because currently it's not set to do anything because we don't use it anywhere in the code. That's about to change. So let me see here now. We have got password length. I'm happy for you, Obi. I think you're gonna have fun. Keypad button. Here's the button. Okay, so we made it on pin number 9, and then we set it as an input, which is what we needed to do. Now we need to read the input of that button. That's our void setup at the beginning. Now, this particular button that we have is not the kind I would have wanted for this, but we're still going to be able to work with it. In my mind, a panic button would lock into position once you've pressed it, to which then it would require a key to unlock the button and cause it to reset. Very similar to the pull station you would find on a fire alarm system, or the emergency stop buttons that are on gas pumps or petrol stations if you're from the UK. Those type of buttons, when engaged, cannot be reset without a key. Right? I would want to do the same thing here, but this button I have is momentary, right? So an emergency button that does not pop back out keeps its current state of either connecting or disconnecting to the circuit, depending on how the wiring is wired. This particular button that I have on the bench has 2 ways you could wire it. The first way is so that when you press the big red button, it momentarily breaks the connection of electricity between both ends. Or the other 2 leads that are tied to the same exact button is the connection is constant, and then when you press the button, it breaks the connection. Or excuse me, other way around. I said the same thing twice. There's no connection, and then it makes a connection when you press the button. That's the way I have this wired. So the button is in an open position, until you press it, and then it completes the circuit. But it does have the lugs on the button to make it so that it's a constant connection, and then you pressing it would momentarily break it. It doesn't really matter because it's hooked up to a programmable board, which allows us to work with either of those logics. Either the circuit's there all the time, or the circuit's there none of the time and then suddenly becomes. And it's just catching that. We'll figure it out from there. So let us see what we can do for that. Okay. So to figure that out, we need to read the status of that big button. So let's see if we can figure out how we're going to do that. Now, I'm going to cheat a little bit here. I'm going to go back to a previous exercise. And we are actually going to use this to tell me which one it was. Because I want to say it was one of the cabin lighting. Yep, cabin lighting. There are the dip switches. So we're going to run with this, because I have this wired just like the dip switches, except instead of there being 3 of them, it's just technically 1. And my action is momentary. It's not all the time. So that's another thing I'm not entirely sure how we're going to figure out, but we'll figure it out. So let's scoot down here. And those were on which pins? So that was on pins 2, 3, and 4. So let's take a look here. So we can see here that pins 2 and 3 and 4 are inputs. And if we look, we can see they are in fact inputs, which is perfect. And then let's see here. So we have a bunch of if statements. So if the cockpit light switch is high, meaning that there's a connection, then we do something, otherwise it's low. So that's how we're going to do it. We're going to do a digital read on those pins, on our pin. So what we're going to do is in the main loop, we're waiting for a button press to continue. So right now, the way that this loop is written, none of the code will continue to execute until something's clicked on the actual keypad. I don't want it to do that. So I want it to be able to allow you to hit the panic button to lock out the system, or put in a pin. So the first line can't be that capture of the button. We need something above it. So we are going to bump that down. I'm debating if I want to put this into a what do I want to do here? Because this is already a loop, and this loop is actually waiting on the keypad press. Otherwise, it's going to proceed without our interaction, which would break the code. So I still need it to wait on that press. Yeah, see, this is waiting for it, so I would want it to wait for either or. Okay. Because the keypad's gonna hold us up here. I think if there's actually a way I can get around that. Because I would need to wait for button input. Because if I put above the keypad input to check for if the button's been pressed, it would only check for like a millisecond. It would be really fast because the button won't be high and it's not waiting on it. All right, let's think about this for a minute. Arduino. Wait for keyboard input or other. Because right now it's going to pause the program until there's a keypad pressed by the way that this is working at the moment. And I want it to be one or the other. Well, if this technically didn't wait for the keypad input and it just ran, right? The button character would not be equal to any of the valid options here. Right, and that's outside the main loop. So technically speaking, it can loop without waiting for that input. Because that's not going to do anything. Because none of the cases would actually be true. Let me try to wrap this inside of a if statement and see what it does. Arduino. I just need to see what the OR operator is. Take a look at the Arduino forms. Oh, it's just the capital E, the parens, and it's the words OR. All right, I should be able to get away with actually just saying that. So let's do if. Oh, I was typed in the wrong box. I want to be down here. If there's a keypad press, I'm gonna just get rid of this comment because I'm gonna wrap this. Or the button pin is set to high. High would indicate that it has completed the connection. Let me syntax check this because I could put the button panic inside of this if statement. As long as the button pin was actually high, we could check for that. If it isn't, then it'll just continue onwards, and then the program continues regardless. So let's see if it takes that. It might not like it. Nope, it doesn't like that syntax. Button character was not declared in this scope. Howdy, Michael. All right, let's see here. Okay, so this is fine. This just simply means I can't declare this and use it in the same area. Come on, Michael. I released it from AutoMod. You're all right. Wouldn't be the first time that this stuff gotten kind of a little crazy. All right, let's see if I do that. Waging a war. Wouldn't be the first time AutoMod lost its kind of collective mind. Oop, I also don't want that semicolon there. All right, let's see if that's okay. Okay, so let's see. Oh, nope, okay. Looks like I actually do need that. Doesn't like that. What else? But pin is equal to high. Oh, I didn't end that either. Boop. And a boop. Well, it doesn't like that. Let's see here. What else did I forget? Compilation error. Expected a comma or semicolon before if statement. Yep. Yep, that'll happen. Expected primary expression before the right token. But it's right there. Maybe it doesn't like the fact that I didn't put a space. I also don't know if that's actually the correct keyword or if I'm supposed to use the pipe symbol here. Not entirely sold on that. Expected primary expression before the double pipe token. What if I could declare that and not try to shove anything into it? Still seems to be okay with that. Oh, you know what? I don't have the digital read. Yeah, that's kind of needed. I can't just throw that at it. I need to actually check against it. Okay, let's see here. Yeah, see, I don't think these are supposed to be here. Okay, alright, I figured it out. It compiles at least. I don't know if it works right, but... Okay, so right now, if the button key is pressed, it gets stored if it does, or the digital read of the button is being connected. Someone pressed the panic button. We're then going to nest another if statement inside of the first one, and then we're going to read it and check for this specific case. And for right now, we're gonna do more stuff. But right now, I just want to print the word panic to the terminal. Panic! Everybody panic! We're at the wrong disco! Okay. Let's see if it verifies. And it verifies. Okay, so I want this to do more, but right now I want to see if at least the logic works. Because in my mind, we then declare the variable for the button character, which I had to do outside of the if statement, which is fine. I then check to see if the key is pressed or the big button has been activated. So someone clicks something on the keypad and the big button hasn't been pressed, well then the button pin won't be high, it'll be low because there's no current flowing through it. So this panic statement gets skipped, and then we just go into the normal keypad mode. If it is high, it's going to write the word panic and then proceed to continue with the regular code. I still want it to break out. We're going to do other things, but let's program it and see if at least if that functions as I think it's going to. So I'm going to send it. All right, the red LED is on, which you can see on the board. I'm going to point with my pointing utensil. Is right there. And we're going to first test the case of the big honking red button. So I'm going to hit it. And oh boy! Oh, we're panicking, all right. It printed it to the screen for as long as I held it. So if I just keep holding it, we're gonna panic ourselves off into the oblivion. Now, the reason that we're panicking into oblivion, right? Let me click one of the correct keys. So this should still function by me clicking one of the keys to go into the system. Let me click the pound key to try to enter into it. Which I have to scroll up here. I forget which one of these was that key. That was third position. Interesting. It broke the program. That just straight up locked me out. The light's on red and I have no way to get out. It's no longer reading the keypad. Interesting. Okay. So let's think about our code here as to why I'm stuck. I've panicked myself into an oblivion. Oops. All right, we still need to troubleshoot that, but let me see if I reset the board and clear the terminal, if the normal mechanism of just using it functions. So, hit reset. Which is going to restart the terminal, and then let me hit a key on the keypad here to go into the system. Interesting, that no longer works. It's no longer capturing anything. Okay. So that doesn't quite work the way I thought it did. So all this does now is just allows me to casually panic if I hit the panic button. That's it. I can't do anything else. I guess it's bad form to put a keypad collect in here like that. Because even though this is waiting on input, it looks like there's no way to actually access it inside of an if statement. Because all that did, right, because that would have been false. Now if I click something, it should have proceeded onwards. And if the digital button was high, indicating I have pressed it, we're supposed to panic. Otherwise, if we get a keypad click, we're supposed to ignore that and then go into the regular program, which we didn't do. We lost our collective minds. The LEDs are stuck. And no matter what I click on the keypad, it doesn't change anything. Because technically I would want to read it at all times. Let's take a look at this older example that we were toying around with. See if maybe I can find some logic in here that might be useful to me. Because in this, we just have an endless loop that turns lights on or off. That's all this does. So we define our pins. Our switches. And then in our setup, the switches are inputs, which is what I did. If digital read is high, then turn on the lights, otherwise turn them off. Right, digital read double equals, and then you close it out. Digital read. Right, we're checking just for that case. I was kind of hoping to put this panic button at the top of the loop here, but I'm thinking I might have to have it so that you have to at least capture a key first. Maybe that's the way we have to go about doing this. See, the trick here is trying to capture something at the beginning of the initialization of the code, because hero keypad.getKey. I can't be the first person who's trying to do this. I'm worried because if I put the check for the simple if statement to look for the button press outside of it, it would wait regardless. Unless I check for it twice. I could check for the button press before I ask for the keyboard input, and then directly after the keyboard input, I could look for it again. But that still gives you a narrow margin. I would like the loop to continue until something's been clicked. So maybe, let's see if there's a way to change the way that we capture that key input. Maybe that's what we want to do here. I don't want to wait on the keyboard. I just want to capture it if it so happens to do something. Yeah, all right, let's change the way we're thinking about this. Key pressed. Let's try this. So don't pause. Because if I can get the code to continue to cycle, that should fix it. I think that's what I need to do. Because then I can continuously check to see if either the keypad or the button's been pressed, and then act accordingly. I think that's what's going to fix this. I think I need to look at the keyboard library. Let's blink without delay. I don't want that. Funny enough, I might be the first person to not want to wait on the hardware. That's exciting. I'm finding a lot of examples on how to wait. I don't want to wait. I want to continue. Keyboard. Let's see what we have here. So we have get key right now is the class we're using. And I think I need to change that for something else. Make sure I'm looking at the right keyboard class. Keypad library. Yep, I gotta look at the right library or I'm not gonna find what I'm looking for. There's a hold time you can use in this. Interesting. I'm getting a raid. Hello, raiders. East Mids Wolf. Hello. I apologize if I said your name incorrectly. I'm not too cool with that kind of stuff. Welcome, raiders. I am attempting to make this big red button that's hooked up to all my hardware panic in an appropriate fashion. Right now we have a 30 days lost in space exercise that we're working through. Well, thank you very much for the follow. East Wolf, if that's an okay way to say your name. I got a plan. I don't know how long it's gonna go here, but let me show you, since you are here to join us. On the bench here, I have the big red button. I have some LEDs, and I think, is it off camera? It's off camera. And this matrix of keys, these buttons. East is acceptable. Much excellence. What were you guys up to while I'm here attempting to figure out how to unmelt my brain? I'm curious. What were y'all doing? Fortnite. All right. Push the red button. I mean, I could push the big red button. Is it still hooked up? I don't know. Let's see. There it goes. That's what it's doing right now. When I press the big red button in the terminal here, you can see it panics real good. I need it to not panic and run the rest of the program. Right now, the program is just panicking, and I'm at the wrong disco. So I'm working on resolving that problem I've caused myself. Because right now what's happening is that the code is not doing what I was hoping it was going to. Right now it's not reading the keypad or the big red button. Ooh, thank you for the follow. I'm gonna call you Chew. That's the end there. Tell me if that's okay or not. The goal is to get this to continue. So either we can enter the system or click the big red button. And the plan, if I can get it to work, is that the big red button is going to make the buzzer go off, and it's going to flash some lights, and it's going to lock out the keypad for a set amount of time. That is the plan. Right now, it's just stuck in panic only mode, which is not where I want to be. Oh, cool beans. I was actually kind of curious to see how you managed to find me. I popped up in your I came up in your recommendations? Okay, all right. I appreciate it regardless. I'm surprised Twitch would recommend this toaster to anyone. I'm here just goofing off and playing with wires and buttons, and it's a fun time. I'm having fun. Well, thank you. Regardless, thank you for rating and bringing your folks over here. I very much appreciate that. I'm a little stuck. I'm a little stuck, and I think that, let me take a look at the examples I have here. Custom keypad event, loop counter. What do we have here? Custom keypad, dynamic keypad, event keypad. Let's see what event keypad holds. Let's see here. Hello keypad 3, multi-key. Loop counter. Ooh, I can view this in here. Okay, let's see here. Right, and then this one just calls get key, which isn't really going to help me here. Serial begin. Fills keypad key array with up to 10 active keys. Returns true if there are any active keys. Get keys. Writes the program again. Pauses until you do something with the keypad. I might not be able to get away with that. I might be stuck with requiring to have to click a button to continue, which isn't necessarily a bad thing. Okay, all right. We're gonna make this happen. And we're just going to add it. Ooh, I heard sound. Oh my word, what are we doing? Wait, no, it disappeared. Who just followed? I missed it. That's a sound I don't know. What is that sound? What is that? I met my follower goal. Okay, cool. Oh, this platform's fun. Oi. Tiny stuff on the screen is tiny. You know, I probably should make that larger so I can actually read it. But who needs to be able to read what's happening in stream? Just a toaster on the internet. It's fine. We'll come out extra crispy. Alright. Alright, here's what we're gonna do. I have a plan. It's not gonna be the best plan, but it should be at least enough to get us moving. I'm gonna scrap the idea of this if statement. And what we're gonna do... You got discovered. Yes, you did. I love that emote. That is adorable. Oh my word. Lunari? Question mark? I don't know, man. You're all coming in here with some fairly difficult names. I'm trying. Your results may vary. Being read out loud from the toaster. Luna, that is infinitely easier. Lovely. That'll work, thank you. Oi. Alright, cool beans. I like that. Luna works. That works infinitely better than what I'm doing over here. Alright, I got a plan. It's not the best plan, but it's a decent one. For now... That's not what I wanted to do. I want to comment these out because I'm a goober. All right. I'm not going to erase it. I'm just going to comment it out because it may be useful in the future, just not right now. Oh, y'all are twins? Fancy. Now hang on. Are we talking like identical twins? Like we can't tell the difference between the two of you? or like you just so happen to be two twins and you don't exactly look. Oh, now listen, if I say Team Rocket, I'm a straight up turn my lamps off, because that's the name of my lamp group. Double trouble like Team Rocket, oh my word. It's true. It is true. As a matter of fact, I have my hover head on, so I don't know how visible this will be. Echo, turn off Team Rocket. Echo, turn on Team Rocket. Alright, so you can kind of see it a little bit. Yes, it's goofy. Yes, I know. I have a plan though. Alright, so what we're gonna do is we're going to check for whether this button is pressed. We're gonna check for it before and after the button press. And then inside of the if statement, we're gonna call the function of actually panicking, so that I don't have to copy and paste a bazillion blocks of code here. So to declare a function that is going to return a void, it's not going to return anything, we use the void keyword and then the give input you call it and then you declare it. So this is gonna call upon a function I haven't written yet, but that's okay. We're going to do that here in a moment. So we're going to call upon lockdown. I'm going to put that in both places. Oh boy. Oh boy. Mabel! Oh god. Mabel, what did you do? Oh my word. Okay. Alright. I am in danger. Hello everyone. Oh boy. Hi everybody. I'm in the method of attempting. It's heavy. Oh my god, Zerafi, that's amazing. I'm having tech issues. Yeah, no, that's fair. Hello everyone. I am actively having tech issues, okay? But they're ones I've created. So you know what? That's valid. That is incredibly valid. Welcome on in everyone. I'm TechHead41. I am the goober who does stuff on the internet. You are my second raid this evening. I very much appreciate it. Mabel and friends, what were you guys doing? I am curious. Hi, Mabel. Welcome. Thank you for completely flustering the toaster. You did a good job. Oh my word. Painting. Oh no! Hold on. Back up the school bus. Put the flashes on. Are we talking IRL painting, digital painting? What kind of painting are we talking about here? Okay. Also, I'd love to know what you were painting because y'all art skills are out of this world. You got some fancy art going on here. Digital painting, hell yeah! That's a whole bunch of fun. All right, everyone. I'm going to bring you guys up to speed on what I'm about to do here. We are doing. It's called 30 Days Lost in Space. And today's the creative day. And on the bench here, I have our circuitry and a big honking red button. What I'm trying to do is make it so that we can panic by clicking the big red button or continuing as normal. That's the plan. Commissions of a background with a character. Oh, okay. Yeah, I think I saw that. Oh wait, is that the commission with like the really fancy starry background? If I remember correctly, it's like a for lack of a better word, a skybox, but a fancy one. Because I can't think of a better phrasing for it. So the goal is to panic at the disco. We just want to do it at the appropriate disco. Which I actually don't want that in there. I want to call the function and we're going to put our panic in the lockdown function, which we're going to declare down here. Okay, so that returns something. Let me actually throw it at the bottom. we can panic down here where there's nothing else to see us. In the void, VOID, because this returns nothing. We're panicking in the void. Lockdown. Lockdown does not call, it does not require anything. It doesn't accept any input and it accepts no output. So right now what we want it to do is just simply spit out to the terminal the words panic in all capital letters. Thank you, Luna. I appreciate it. I think I'm on to something. Hopefully this still compiles. You're gonna check quick. Oh, I did a bad thing. What did I do here? I missed a semicolon. Where did I miss a semicolon? Expected a comma or semicolon before if statement. Oh, oops. Boop. Boop. That's better. I missed a semi. It's not your Starry Night YCH. It's based on the same idea for a detailed background with structures, plants, water, and more. All right, lovely. Very lovely. Well, I saw several examples in a couple of different Discords, and they look really nice. I think you do a good job. I mean, I saw what you do with a spoon, so I mean, anything is possible. Hi, an HD spoon. I love that basically became a meme. Right? Am I right? I feel pretty right. Okay. All right. Let's see here. It was a good spoon, and it was also a spoon with depth and shadow, if I remember correctly, which was an awful lot for Lay Spoon. For picking up things and pushing them around again. Picking up what I'm putting down here? Oy vey. Okay, I've got a plan here. It's not the best plan, but it's a half decent one. Yeah, metallic painting. Water renders that. Oh yeah, by all means, Maple, enjoy the foods. Glad you had fun. Okay, let's see here now. What I want to do is I want to only briefly wait for the panic and then continue the code. So let's see if I could add a conditional delay to this. Because right now I have it wedged in the middle here. What's your idea, Mountain Man? I'm happy to hear it. Because what I'm cooking up is not exactly perfect, but I still think it might work. Let's see here. You know what? If I put this if statement inside of a loop, I can loop and wait for it. Maybe that's the angle I go for here. Or I put it in a loop, and the breakout I give it is going to either be that the condition's true, that the timer runs out. Oh. All right, that's fair, man. That's fair. It's fair. Very fair. Yeah. Let's do this then. Let's do a... Let's see if I could do like a do while loop for 10 seconds. That might actually get us where I want to go here. While can block other code execution during that condition. Should be used in situations where you know it will finish quickly. For general testing delay, thousands, okay. What is blocking? Also, so for speed, handle this differently. Well, let me throw in just a delay here and see if that will give me what I want. So let us check for in milliseconds. So let's check for 5 seconds. That'll pause the code. So in theory, that should give me the ability. Ooh, a follow. Hello. Tazero, if I said that correctly. Welcome on in. All right, this should give me 5 seconds. Yes, I am a protogen. I am very green. I'm very green. I'm very proto-shaped. I mean, come on now. Proto, gen. Also, out of curiosity, do you notice the symbols on the side of my visor here? Does it look familiar? Because that is a color code for something. Let's try this. So I'm gonna send the code, go to the serial monitor. 5, 4, 3. Oh, I wasn't fast enough. Okay, so I'm beyond the point. The button no longer does anything. So let me rerun it again. Upload it. Nah, it's too fast. That delay doesn't work the way I'm thinking it would. What are those? Well, I'll give you a hint. It has to do with networking. Those colors mean something in the networking space. And if you can't quite make out the colors, because I do realize it's a bit of a distance. Orange, white, orange. Green, white, blue. Blue, white, green. Brown, white, brown. That's the color order that's also on the side of my visor. A simple delay won't work. While can block other code execution during the conditions, can make your sketch unresponsive or run slowly. While or do should be used in situations where you know it will finish quickly. Example, less than a millisecond. We should always attempt to write non-blocking code so as to service all items as fast as possible. You are correct, it is the wiring of an Ethernet cable, but the question is it standard A or standard B? The difference between A and B is the difference between the orange and green wires in that they're switched. You got two options, it's either A or B. But man, I feel like you're gonna know the answer to this question. I think we're gonna make this a do while. Yeah, do while condition. Okay, so let's do this. And I have to be careful because it added its own closing brace. Gotta be careful of that. What happened? Oh, I didn't provide the while. It's the B standard. Yeah, do this while condition, so do this. While the condition. We got 2 raids, Pyro. Hello, welcome on back. All right, here's my thought process here. If I go into this loop, I just simply want to check to see if this is the case or not. Pyro, I'll give you the other one in Messenger here. Thank you for returning, by the way. There we go. Yeah, in DMs you'll have it. Please and thank you. All right, so we'll say int I is equal to 0. And then after it checks once, we'll increment it. And then while I is less than, we'll say about 2000, we'll keep checking for it. We'll see about how long that runs. Oh. I have to declare it here, don't I? what? I'm confused. Wait, I should have to declare that before I use it. Yee! Sounds good. Thank you for stopping in. Again, appreciate the raid. Alright, I want to do this or that. Because I'm doing it within the scope of the do loop. But it doesn't like it there. I definitely don't think it's gonna like that. Yeah. Oh, that's why it's bargain. I didn't put the semicolon on that. I was not declared in this scope. Well, it's right here, so why don't you like that? Let me take a look at my for loop that I used up here. I say up here as I scroll down. Because I used the for loop for capturing the pin earlier. Yeah. I mean, I could do it this way. Do a for instead. And then just check a total of like 4 or 5 times. That should give you a couple of seconds to be able to click the button at the beginning of the program. Because the trick is capturing it when it actually happens. Because it can't be checking for it all the time. The code doesn't work that way. So let's try that. So instead of a do while, alright, so let's do that, and then while I is less than our hard-coded 10, thank you for stopping in, Mountain Man. Appreciate it. Alright, this compiled. This should mean that this should run a total of 10 times, which should give us hopefully enough time to be able to click it at the beginning of the program to cause it to panic. Yep, I caught it. Now here's the trick. Does the keypad still work? It does, it does. Okay, all right. No, enter pin to continue. Beautiful. And it let me in. Welcome, authorized user, you are successful. Okay, cool. Let me clear that. I'm gonna reset the board by clicking the little reset button on it. Alright, so I should have missed my opportunity now. And I didn't. Interesting. So I can do that. Enter pin to continue. Interesting. Interesting, that worked the way I wanted it to, but not the way I thought I needed to write it. Let's look at this again. Because this for loop should run pretty fast. Right? So I'm looping and looking for this. A total of 10 times. And then I got the key press from my other keypad. Now, oh, that's why. Because once the function, I let go of the button, the code stopped its execution. And it came back to the top. So it actually got trapped in this loop. As long as I continued to hold down the button, the code didn't proceed. It stayed right here. And then when I let go... Well, here's a question then. How long can it sit for then? Because I would think that that shouldn't work indefinitely. I would think 10 iterations of this statement would go fairly quickly. So I would think. All right, let's check that then. So in the loop that I'm running 10 times, I want to print the letter I, or the variable I rather. Okay, it's within the loop, so I should be able to get away with that. That means I should be able to see when it counts to 10. At least how fast that is. Is 0. Well, I is less than 10, increment. Interesting. I'm not getting a count. Oh, hang on, I put that in the wrong place. I put that in the for statement. Wait, no. Hang on, so 4, that opens there. Oh, I need to put this down a bracket. That belongs down there. We should see it count to 10 on the serial monitor. Huh. That's an interesting issue. Technically to 9, because it would be 0 through 9, which it would be the 10th position. Because indexes start at 0. Interesting, so this is just looping indefinitely for this for statement. For I equal to 0, I is less than 10, increment I, so it runs the first time. Yeah, and it is resetting itself. And if I hit a keypad press, it stops. That was the wrong digit. Or I could hit the panic button. Yeah, it panics pretty quick too. Panic! We're panicking! We're panicking so fast! Alright, well I got the solution I wanted. I am not entirely sure how this works. But that's what I wanted. I wanted it to be able to accept me clicking the button, or continuing the program by clicking something on the keypad, which stops the loop. Interesting. Right, the light went green, the system was accessed, and the loop picks back up again. So instead of it getting caught, because my issue, chap, before all of you had arrived here, is I was getting hung up on the button press for the small keypad that I have on the bench here. What was happening before is that the code was waiting for me to click something on this keypad instead of the big button. I can click the big button now, and it says panic, and it actually does register as so. Interesting. So now it's just endlessly looping. Because for I equals 0, well, the condition should be true at some point, and it should break out of the loop. But it doesn't for some reason. Alright, well, when you strike gold, you don't necessarily question it. I am more than likely going to dig into that further after stream, because I actually do want to do the other stuff to make this work. Now that it's working, I don't quite understand why, we could do the other stuff. So, when we click the panic button, we want two things to happen. We want the LEDs on the board to flash, and we also want there to be a sound indicating we've clicked the button. And then also putting in the terminal, like, hey, that the keypad's locked out, you know, giving some kind of indication that you've locked out the system. So let's do that. That's pretty easy to add, because we're just going to scoot on down here past a lot of this stuff. And we're going to grab some of the code that I already wrote down here. We're going to give it a good reuse. So I'm going to grab some of that. I'm then going to flash both of the LEDs on the board on and off. I've got a red one and a green one. So we're going to turn the red LED on and the green LED on. We're then going to delay. For probably, what, 200 milliseconds? So that's like 2 seconds. We're then going to turn it off. And then while it's off, we're going to indicate with the buzzer. So we're just going to reuse the function here that actually makes these two like womp womp sounds. So yeah, we'll panic. We'll flash both of those. We'll play the sound. And then we're going to do the thing that's going to be quote unquote locking out the system, which is just going to be a delay in the lockout. It's just going to be hard coded to wait. The code won't proceed for the amount of time we put in the delay. So we do want to tell the individual that we have locked out the system. So we are going to actually say on the screen that we've done so. So we're going to say that the system has been locked out for 500 seconds. Actually, that'll take really long to loop through. Realistically, we'd make this more. Let's just say 5 seconds. And then we're actually going to delay a total of 500 milliseconds or 5 full seconds. We're going to compile it. I'm going to forget something like a semicolon. those little buggers know how to get away. We'll push it to the board. Okay. I'm going to clear the terminal. And I'm just going to restart the code on the board by clicking the reset button again. Just so we can see the terminal from fresh here. So, if everything works according to plan, I'm going to click the big red button. And that's going to cause our terminal to go into a case of panic. Right now, we have our red LED and the green one is off. When we click this button, these should blink on, off, the buzzer goes off, and we'll see a message on the display. Panic, system locked out for 5 seconds. Okay, so the buzzer did in fact go off. And in our terminal here, we do see the message panic, system lockdown for 5 seconds. Now, one more thing this needs is the going back to ready state. For those of you that code with Arduino, you would know that there is a setup section for the code that only runs once, and then the loop takes over from there. We're actually going to grab some of the code from the initial setup function and run it again. So I'm going to go up here. And I'm going to grab, I won't need the serial begin, but what I am going to need is the state of the LED and the message to the screen. Because what we won't know is we won't know when the system resets if we don't tell the user that it's actually been reset. So we see here that we're going to turn the red LED back on, and then we're actually going to just run our normal message to the screen again. Okay, I'm going to push that code. Okay, so you can ignore that message there. I'm going to click the panic button. The lights went off, the buzzer went off, terminal locked out. And there's our message. System locked down for 5 seconds, and now we're back to the normal method of getting into it. So now from here, I can click the star to enter into pin mode, and then put in our 4-digit pin, which is in this case all zeros. We get the success message, and then on the bench we have now got our green LED. And then now that the loop is basically started back over, I can actually hit that again and lock up the system. System's locked out for another 5 seconds. Okay, so we have incorporated our big button, and we've gotten this almost to the point of it being functional. There's one more thing I want to see if we can do to it. And right now, if I put in the 4-digit pin to unlock the system, what ends up happening is that it's perfectly fine until the board loses power. Right now, it's just holding on to the current pin, and then it's stored in memory, But if power disappears, it resets to the factory, which in this case is 4 individual zeros. 0, 0, 0, 0. Isn't doing anybody any good. I obviously would like it to hold on to that when it powers off. So this is going to require additional little bit of research here. Let's see if we can figure it out. So first things first, I'm going to make sure I've saved this, because this has come a very, very long way. What we would want to do is we would want to read from memory the pin that we have. And if one isn't set, then we would want it to be all zeros. So there is the function called EEPROM write. Just like the storage in your computer that holds on to the stuff that's on your hard drive, where your pictures, your music, your fun things that are happening on your computer are stored, the EEPROM is similar to that. It's kind of like the hard drive, it's just the storage that holds things when the power is off. So there is a thing called EEPROM. In that, we need to include in our code. So before we can interact with any of the classes, the libraries that are declared, we need to include them in our code before we can call them. Because you can't call for somebody if you don't tell them to be present. So EEPROM is the one that's going to allow us to interact with the memory of the microcontroller. We'll leave ourselves a nice helpful comment there to remember what that is for. Alright, now this example allows us to do what? The current address in the EEPROM, which byte we're going to write next. Int address equals 0. Void setup. There's nothing to do in setup. Divide by 4 because analog inputs range from 0 to 1023. Each byte of the EEPROM can only hold values from 0 to 255. Okay, so we won't need to do any math here because a 4-digit pin is, well, 4. 1 byte of memory, which the Arduino Hero I have here, I believe has 255, I think. The example here, I think, is the Uno, which is a different hardware package, but the example is going to work the same. A byte of storage can hold between 0 and 255. If you're trying to hold something bigger than that, then you need to actually break up, like it's doing here in analog values, between 0 and the numbers 223. Splitting it by 4 allows you to fit it across 4 different bytes. We only need 1 because the number 4 is between 0 and 255. So I actually don't need to do that part right there. What I do need to do, though, is write the value to the appropriate byte of the EEPROM. These values will remain there when the board is off. So address, and then this says the address and the value. So let's see, advance to the next address when at the end, restart at the beginning. Larger AVR processors have larger EEPROM. Arduino. Oh yeah, right here. So the Arduino Uno is a 1 kilobyte of EEPROM, which would be, I think, 1024 bytes, I think. And then the Mega's chonky, that's 4 kilobits, which is hysterical because we all think in gigabits and terabytes now. And here we are on this developmental board that's using basically peanuts in comparison. This will make your code portable to all AVR processors. Address is equal to address plus 1. If address is equal to length, so if it's address is equal to address plus 1, EEPROM.length. Alright, well that allows you to shift some stuff around here. As the EEPROM sizes are powers of 2, Wrapping prevents overflow of an EEPROM address. It also doable by a bitwise in a length of -1 or length -1. And then delay. And I would think to pull it back out would just be EEPROM.read. And then you would just throw it into a variable. Alright, now this was done before setup, so let's do that. So above our setup, it's right there. I'm gonna wedge that below it. I'm not putting anything in setup, and I don't need to divide what I'm storing by 4. But what I am gonna need in the EEPROM is what's gonna get written. Now, this next part's going to be a little dicey because when the code first runs, I want this to be 4 zeros. And before we actually dig into that, I'm going to put a little marker next to that line because we're not done yet. So we're going to come back to line 42. Because we only want to write to memory if the pin changes. And then we want to read it back out again. So when power comes back on, you can still get back into your system with something that's not the default. So let's see how the pin was initially stored. So we want to go down to the pin verify section to check on that. Validate pin. Okay. So it's in an array. The password. It's an array of 4 individual zeros, which means that when we want to pull it back out again, we would want to handle it like an array. That's what we would want to do. Now, I believe an array will fit in a byte. Let's scroll back up and see how the initial one was declared. We should probably be okay with that. Also have to check to see where that's declared. They're chars. That might potentially cause some problems. But we'll see. And the reason that it's chars instead of integers or a byte is because there's letters in here in this keypad. This keypad has 1 through 3, 4, 5, 6, 7, 8, 9, star, 0, pound, and then the letters A, B, C, and D. If I didn't have those letters in there, then it wouldn't need to be chars, or the pound or the star. But this is the default keyboard layout in most projects. So to not lose what we're doing, I have to see how difficult it will be to store that. Or it would be kind of inefficient. I suppose I could always tell it to store the pin across 4 different memory addresses and then just pull them back out and stick them back into the array, 1 address at a time. I could do that. They'll take up 4 bytes though. I don't know if I care. Should still work. I'm not exactly low on space per se. Well, let's take a look at the example and see. So that's what writes it, and then the memory address. Current address in the EEPROM. EEPROM write address and the value. Address plus 1. If address is equal to the EEPROM dot length, address is equal to 0. I don't quite understand what this part's for, though. It says it makes it compatible, but I don't see how or why. It gets the length. But I don't see how that makes it usable. Log read 0/4. I don't know, let's try with it. Let's see let's see if we can break it. I kind of feel like we're going to, but that's okay. I think the easiest thing I can do here for testing purposes is just hard code some stuff in here and see if I can get it into and then back out of what we have. So let's do this. Let's just do address 0. I'm tempting just to hard code these in here. I might just do that. And then our value. Well, let's do this. Let's do a value of 1, 2, 3, and the letter A. And then we're going to put that in address 0 through 3. I do realize I could have made this an array, but this is where my mind is going, so this is what we're doing. Alright, so address 0, 1, 2, and 3, and then write to EEPROM address 0, 1, 2, and 3. Let's see if it'll A, verify, and then B, if it'll let me go. Okay, so it's telling me right here, EEPROM does not name a type. Does not name a type. I mean, it doesn't name a type. Oh, you know what? I didn't put these in parens. That's probably what this needed. Or quotes, rather. Because these were values instead of variables. Nope, doesn't like that. Where's my declaration for EEPROM? It should be up here, isn't it? It is. And that's a part of the locally installed packages, so it's not like I forgot it. Yeah, if address is equal to address plus 1 EEPROM.length. Honestly, I'm kind of just curious to see what this will return. So let's take a look at it. Strangely enough, maybe EEPROM doesn't actually start at 0 for the storage it could hold. Maybe it does start at 1. I would find that hard pressed, but anything would surprise me at this point. Serial print line. Alright, so let's go out to the terminal. Well, thank you for the follow, Midnight Wolf. It's good to see you. Do I have any beans to make soup out of? I don't think so. These are all green beans. Oh, I forgot that thing. What? Serial does not have a type. Serial does not name a type. Oh, I mean it doesn't be. Did I mess this up? Soup out of green beans. I mean, you probably could. I don't think anybody's gonna stop you. But this is a variable. I couldn't possibly be putting this in quotes. Maybe I can't actually put that there. Maybe that actually has to exist down here in initial setup. Alright, I'm pretty sure that's going to print the literal phrase, but let's just check that first. Yeah, okay, that printed the literal. I don't want the literal, I want the value, which I kind of figured. Alright, let's see if it'll compile though. Okay, that part seems to be okay. Let's see if I can get a length now. Alright, well there's my answer. 1024 is the byte length. So there are 1024 addressable spaces in this EEPROM. Okay, that's good to know. So that must mean that what I'm trying to do just can't exist up here. This has to go in the setup, probably, for it to work. So let me get all of that out of there. And let's stick it down here in the setup. First, let's see if it'll verify or if it'll still bark at me. Okay, so it didn't get upset that time. Alright, so let's do this then. I wrote that to memory. Let's read it from memory. Let's do a serial print line. Let's do an EEM from dot read let's read what I put in address number 3. EEPROM was not declared in this scope.
It's not exactly clear whether they even
I don't think I spelled it right. No, I did not.
in the physical universe. If they do, if one day physics finds a use for them,
Nope, I think I made it extra mad now. Oh god, that's a lot more. That's a lot more error.
that's great too.
A matching function for call EEPROM class. Interesting. So read's not actually. Okay. Interesting. How do I get it back out? I put it in there. I shoved it on the shelf. Apparently read is not what I need.
Tiny planet it lives on.
Alright, well, let's see this other one here. This is another example I had that I was tinkering with. EE address equal size of float. Ooh, okay, yeah, we'll try that. Let's try get. Ooh, Midnight Wolf, I think you're onto something. Okay, so it did technically quote unquote work. But I did the wrong thing over here. Ooh, Bloody Snow Leopard, thank you for the follow. I meant to put in here a memory address, and not that. Hey, I appreciate the cheer on. I very much do. Because let me tell you, it is a very, very involved disaster I'm causing myself here.
If they do, if one day physics finds a use for them,
Functionality to get input objects to and from the EEPROM.
that's great too.
Template get int, and then I don't know what this second value is supposed to be. I don't know what that is. All right, so the next part is figuring out the second half of the get, because obviously the first part has to be the memory address, which I did give it. The second part is going to be whatever this other thing is that it wants. So let's see what the other thing that it wants from me. Wonder if maybe it wants the type of thing I was storing. Let's see what the get is. I'm sure I have another example here. Float f is equal to 000f. Variable to store data read from EEPROM. This may print off NAND if the data inside EEPROM is not valid. Oh, I misunderstood this. Okay, so I have to actually, I'm getting it out of memory, I'm putting it into something. Yeah, Midnight, you got it. So this is then where I'm actually storing it. So the letter A was actually the name of what I did here. So I kind of boo-booed this. So this is gonna just be I'm just gonna fully spell out the word address 3 for that. I need to get it out of the serial statement though. I have to declare this first. I can't just use it. And then according to what I'm doing here, I want to see if I can just store it in a char, which is initially what it was in the first place. Oh, yeah, no, you're right. That char address 3. And then I need the close on it. And then this doesn't actually go there. That'll go there. And then I'll actually print what was in that, like that. What did I do here? I missed a semicolon. So now, if I clear the terminal and I run the code, this should print the letter A, because that's what I stored in address space 3, if I did this right. Almost. I almost got it. And I think that's in part of the way of me storing it, because when I stored it, I didn't give it, I gave it the value. I feel like I'm so close to getting this. Because in the example I'm looking at here, they used a float, but I don't really believe I'm going to be able to shove a char into a float. I feel like that would cause me a pretty bad time. This shows how to use the EEPROM.get method to preset the EEPROM data, run the example sketch, EEPROM put. Ooh, okay. Well, let me look at the put sketch then. Because I used a different one, so maybe I have to put it differently to pull it back out for it to actually be readable. EEPROM.put. And it's probably what I'm supposed to be doing, is putting and getting. Yep, because if you call put, you have to give it the address you're going to stick it into. And then... No, that's technically the same. I think write and put might be the same thing. Well, let me change it anyway. It's not going to hurt anything. The address and the value. Let's validate that. Okay, validated. The address is... and the actual value. Alright, well, let's give that a try and see what it spits out. If anything. Hey, hey! Look at that, I got a letter A. Okay, so that's how we put things into and out of EEPROM. So now that I know how to put things in there and pull things back out again, we can actually use this to our advantage to stuff our pin inside of the memory so that it makes this a more functional keypad. Okay, so this was our lovely functioning example that I'm not going to remove, but I am going to comment out, just so I have it for reference. So then I can grab that, I can move it around. Okay, so first things first, what we'll need to do here is I want to see what happens if we don't supply anything to the memory address. If I just try to read a position that I didn't write to, I want to see what happens. So let's actually do this. Let's partially comment some of this out. Let's get those. And then let's just try to read memory address 3 without trying to put anything in it. Clear the terminal and push the code. Curious to see what it's going to return. Okay, I need to actually reset the board because that was written to memory. So yeah, hang on. I gotta. Can I do that? Let me try the reset button. And it's in memory, so it's gonna read it. Well. I've been turntabled. Yeah, midnight, I think we're gonna do that. Because all I want to do is I just don't want to overwrite the pin that we're going to store in memory that's in there right now with the 4 zeros. Like, this part has to disappear. I need it to either be 4 zeros, or if there's something valid in there, like have the ability to modify it without hosing it. So let's try that. Let's read address position number 4. I just stick 4 in there, that'll be position 4, and I haven't put anything in there. So let's see what's in there. I would imagine it's going to look like some kind of gobbledygook, or maybe it'll pull back some kind of weird letter. Yep, okay, so it's an invalid character of some kind. Oh, I'm sorry, my head's in the way. It's some invalid character of some kind. It's just a square. So, initial out of the box experience, I would want to be all zeros. But once we've put something in there, we need to check to see if what's in memory is a valid character, or in this case, 4 valid chars. Doesn't matter which ones. Well, technically it would matter. It would have to be something on our keypad for it to actually be real. So we would need to just check to make sure that the pin is one of these. For any 4 combination of these is what we would need. Right, it should never be undefined, but there's also other things that exist in the ASCII space that are outside of these digits. So like, if for some reason, if a / was put into memory and saved, you now have essentially bricked the keypad, because now there's no way to successfully enter the 4-digit pin. So I need it to be only those valid characters. Yeah, 100%. So we're almost there. We're almost there, because it's easy enough to set the memory with the pin change. All you have to do is just call the EEPROM write in the section where I'm already setting the pin and saving it to memory. That part's easy. What we're doing is the harder part, making sure that we don't overwrite it. So during the area where we first boot up the code, we need to confirm that that character exists in the list. Okay, alright, I think I know how we're going to do this. We're going to use a for loop, and we're just going to cycle through the available options, and as long as all 4 digits that are read out of memory are a valid option from that list, then we know that the pin is valid. We don't care what it is, but it would be something we are able to type. Otherwise, if one of the 4 positions is not a valid character, we're going to reset it to all zeros. So then you can actually get back into the keypad without having to reprogram the board. That's what we're going to do. So to do this in a way that my brain will understand, I'm gonna copy this. And I'm gonna put that on my notepad. And now we are going to do, scoot down to the setup section. And then I'm just going to comment this back out because I don't need it right now. And then here we're going to make a, that's how many, it's 1, 2, 3, 4. Should be able to use, well, let's just be a list of chars. I should be able to do this by just doing char valid options, and it's going to be a pair of, let me make sure I'm declaring this the right way. I need length. Oh, that passed the value of how many positions. Oh, that's right, because I'm declaring how big of an array this is going to be, and then its values. So then this one is going to have to be a total of 16. With the available options being, was that square brackets? Yes, that is the curly ones. And then I'm just going to combine this. Instead of it being a 2-dimensional array, a 1-dimensional array. And this will save me from having to retype all of these. All right, let's make sure I declared that correctly. Okay, good. I did. It compiled. Yeah. All right, great. So those are all my valid options. And then this is just as simple as doing an if statement. Actually, technically, let me think about this for a minute. I gotta loop through all the options. Right, I got 16 options. 0 through 15, if we're indexing thinking. So if I just do a for loop similar to what I used to accept the pin, validate pin, Alright, this will actually be 2 different loops. Because I have to loop through all 4 characters 16 times. So I already know the pin length is going to be equal to 4. And we're going to read the memory addresses of 0, 1, 2, and 3 to store our pin. So that's where we're planning on reading them from. So if I tell it that 4 times I need to read what was in EEPROM. That was the put. And this was the get. Where int j is equal to 0, while j is less than um 16 increment j. And then what we're going to do is we're going to say if the EEPROM read of any of those 4 memory addresses are bad is what we're going to do. So if I really should write this as an array of integers now, because otherwise this is just going to hurt. I'll have to check all 4 positions of the EEPROM. So I need to get it and store it. Actually, I'm making this too hard on myself here. So if... Alright, so now I actually do need this, and I am going to stick it up above. Because I need to read what's in memory in the startup, and then figure out if I need to get rid of it or not. 1, 2, 3, 4. Address 0, 1, 2. And then address 1, 2. Oh, nope, I messed that up. Address 1, this is address 0, 0, 0, 1, 1, 2, 2, 3, 3. Okay, so then I can say if Yeah, okay, this could just be a combined or statements. That will make this less frying. So if address 0 is equal to valid options index j, so that's gonna loop 16 times and go through all the valid options. Or one or address 2 or address 3. So that gets us address 0, 1, 2, and 3. So if any of these are not equal, I want a not equal in here. Oh yeah, you're right, Midnight. This is gonna have to be an and. Actually, yeah, no, I could do it this way. If not equal. If any of them are not equal to it, then it's a problem. I don't care which one, as long as they're all valid. Yeah, I'm gonna do it that way. Yeah, so if address 0 is not equal to one of the valid options, or 2 or 3, then we're gonna set the pin to be all zeros. That actually allows me to here's what we're gonna do. I'm gonna copy this, and I'm gonna have to modify that up there, but I'm just gonna bring that down here. Like that. That will reset the pin. Now, I don't have to declare it down here because I'm going to declare it up there. So right now this should still compile, unless I made a mistake somewhere here. Alright, I made it mad. What did I do? Address 0. Did I forget to declare something here? It's upset about this block. Cannot convert brace and close initializer list to char in assignment. Oh, you're right. I didn't declare them above. I see. No, you're right. It isn't declared. Because I had to declare them up here. Like that. I just have to do that for the 4 of them. Because I have to declare them before I can use them. Okay, so that made that stuff happy. What does it not like about this? I did declare it up top. Is it not happy with it down here? Cannot convert brace and close initializer list to char in assignment. I could, but what am I comparing here? I'm comparing address 0. Would have been a char. I think it's upset about the if statement, the top portion here. Password pin length, exit status 1, compilation error, recent close initializer list to char and assignment. I mean, I don't think I need to redeclare it because it's declared up top. Or maybe I do. Okay. That's alright with me. Now this is working correctly. Then the only time that this would basically reset it is if what it pulls out of these memory addresses is something that's not in this list, preventing an improper pin. Now, for the time being, with the way the code is right now, I left up here in the top that the password pin length is all zeros. So in running memory right now, it's going to be all zeros. So let's send it and double check it to make sure I didn't break anything. Because right now it's not reading from the memory to make it usable. It's just simply reading it to confirm that it's valid. I don't actually have it doing anything with the pin itself. So I should still be able to get in here with all zeros. Yep, I've successfully unlocked it. The green LED illuminated. And the panic button panics. System lockdown for 5 seconds. And then the LEDs reset. And I can access it. And I can panic to reset. Okay, all right, that works. So now I've confirmed that what's in there is valid. I guess for my own sanity's sake, for debugging purposes, I would like to spit out to the screen just for the moment. I'm going to comment it out. What is in those memory addresses? Because I do want to see what's in them right now, but I wouldn't want to leave it in there just to make sure this is working. Because as far as I know, I've only stored the letter A. So technically that shouldn't have worked unless... Did I write to all 4 of those in my previous? I did. I 1, 2, 3A. Okay, so it should be 1, 2, 3A that I actually put in there. So actually, yes, there is valid code in there. And if I were to read that to the screen briefly here. Let's see. So that for loop ends there. I don't want to loop this multiple times. On separate lines. Clear the terminal, send the code. All right, that's beautiful. So in memory, what I stored earlier is still there. 1, 2, 3, letter A. So now what we're going to do is we're going to make it so that what we enter will actually be stored inside of memory. This is the easier part. The harder part was making sure that this actually functioned as intended. So this I'm just going to flat out get rid of because I don't want that to come to the screen. And that is going to involve our put commands that I commented out from earlier. We're going to scoot on down to the function that allows us to change the pin. So star calls on validate pin, and as long as it's valid, it then goes through the process of capturing the pin. It gives input feedback, the stars, and then in the section here where the pin was successfully changed, this is the part where we're going to actually add it to write it to memory. And that is going to involve us passing instead of hard-coded values, let's see here, so it looks like it captures it and loses it. Okay, so actually we gotta be careful with this. Or does it? Password position I. Oh no, that's fine. It just overwrites what's in the variable. So this I can pull down here, and then instead of those markers, the letter I, I'm actually just going to tell it to pass all 4 of the valid positions of the password. So this is going to become a 0, that's going to become a 1, and 2, 3. Oh, that was declared outside of the scope. That's my bad. That's fine. That's super easy to fix. That's right, because this function is outside of the initial setup. Which means actually the easiest way to fix that would be to make these global. And the best way I could do that is putting them at the top. Yes, I can. That's what I'm going to do. So these need to go above void setup and exist up here to make them global. Global means that they are accessible anywhere in the program, including down there where I really need them to work. So now, no more error. And I could scoot down here to where I was. There we are. No more red lines. Because the address positions are now available everywhere in the code. And then I actually just pass it the 4 different positions, give the successful feedback sound, and then we're good. If for some reason there's an issue and it wasn't successful, then we don't write it to memory, we access deny it, and then the system's reset. So that's what we're going to do. I'm going to validate the code. I'm going to send it. Oh, let me clear the terminal again to make it visible to y'all folks. Kaboom. Okay, so I'm going to reset the board one more time. Okay, so now, if everything worked according to plan, I'll be able to access the system with all zeros. Hit the panic button, which will lock me out. Change the pin, And then that is going to go into the system memory. Ooh, I'm missing something. I need to read those values into memory. I think I forgot to do that. We validated that they were... This is if they were not valid. I forgot the little tidbit here that if they were. Else the char of password is going to be equal to the 4 different values we pulled from memory in the order that we pulled it from memory. So address 0, address 1, address 2, and address 3. Now, right now there are valid values in memory, which means that when I send this code to the board, the default of all zeros will no longer work. Even if I left this up here in the top, which I am going to comment out, technically I could leave that there, but it won't work because once the code gets down here into the initial setup, the void setup is going to run and those all zeros would get erased, technically speaking, unless there were invalid characters. Otherwise it's going to load them from memory. So it was currently set to 1, 2, 3 letter A from what I stored in memory when I initially manually did it. So I'm going to validate. Oh, yep. Yep. Oh. Ooh, okay, I can't comment that out. I have to leave it up there. I'm just gonna remove the part where it declares the default. Because it needs to be declared up here, otherwise it's gonna be mad at me. I scrolled past it. Where the heck is it? There it is. Right. It's gonna be declared up here. I'm not gonna set it to anything. Because it doesn't need to be. So now, I'm gonna clear the terminal. And then I'm gonna send the code. And now this is gonna make it so that all zeros should no longer function. It's going to read the last thing I had in functioning memory. If I did this all correctly, it's going to work. So I'm going to try to access the system by clicking pound. And then I'm going to purposely try all zeros, which shouldn't work if I did this right. Wah wah, access denied, it's sad. Now I'm going to put in what I hopefully got is 1, 2, 3 letter A. Ooh, that's not good. 1, 2, 3 letter A. That was what it was supposed to be, unless I did something wrong here. I've locked myself out. Uh-oh. Panic! Panic! Doing all the panic. Wrong disco. That's exciting. What did I do wrong? Oh, I did something incorrect. That's exciting. All right, this is the part where we're going to debug. All right, let's see what I stored and how I did it. So up here we have the initial length of the password being 4. and I'm not setting anything there. So there is our keypad define. And then we capture the key with that object we create there and its pins. There's our memory addresses. Let's make sure I got this right. 0, address 1, 2, and 3. So 0, 1, 2, 3. And we scoot down here. We then declare. Oh, I see what I did. I declared 4 empty char variables. I set them in here, but I didn't actually get them out of memory. No, wait, I did that right here. Address 0 is address 0. Right, that actually was supposed to set them. 0, 1, 2, and 3. 0, 1, 2, and 3. And then the password actually was being set. 0, 1, 2, and 3. Okay, so that is where we're supposed to initially wander through. Yep, I think that's what we're going to do. Because I'm not going to lie, I'm a little lost. I know what I put in memory. Address 0 is 1, 2, 3 letter A. 1, 2, 3 letter A is the whole top row. And I don't believe... Was I holding the keypad incorrectly? I don't think so. Well, let's write it out and see what is stored in memory. I think that's going to be the easiest answer to that question. So right after it loads what's in memory, because I wouldn't obviously need to know if it was something otherwise. Actually, don't know if I can do it that way. I'm gonna see if it'll let me get away with doing it this way. It might not let me. No. I wonder if I use plus symbols. Or if I just use spaces. Usually compilers don't like spaces. Actually, let me look. Let's see what happens. There's gotta be... I could definitely do this on one line. You can't tell me I can't. Yeah, print multiple variables in one line. Serial print line. Weird, it actually does make me do it. Alright, fine, I could do it in separates. Doesn't really matter to me all that much. I just want to see what's in them. Alright, let's send it and reveal to the terminal what the pin is. Well, isn't that interesting? That means that it never loaded. It never got to this condition. That's why it didn't work. So the pin was set to nothing. So there was nothing I could click that would actually let me in. That's interesting. So if not valid, I used J for the increment, which should have ran me through all these positions. Realistically, I don't think I would have needed additional loops. This should just work in one. Because it would take position 0, which would be a 1. So if address 0 is not equal to position 0, which is a 1, then that's going to cause us to reset the pin. Or the same thing for address 1, 2, and 3. Otherwise, they would have all been true. So then we would have wanted to set the pin from what we had in memory. Alright, declared what they were further down, which actually I did write them, I did make them in this scope. But password is global because it's at the top. Okay. Right, well, let me think about this. So I had two separate for loops here. Was that even really needed though? I guess technically I didn't need the first for loop, which would go through all four. No, I don't need that. That shouldn't have prevented it from working, but I shouldn't actually need this outer for loop. Because I don't have to run through all four iterations of the pin if I'm checking all four options that I could potentially have that would be in my password. So this should technically be extra and not actually needed. It really shouldn't matter. Yet I still don't get anything to the screen. So either again, this isn't running. Print J while J is less than 16. Increment. Password length. Right, and I'm comparing a char variable against another char. And I go through all of the available options. One address at a time. All right, I'm going to do something here. I'm going to move this out of here. Remove this else statement altogether. So that this if statement only resets the pin if it's not valid. Which I have my doubts of whether that works right now or not. I have a way to test that, but I want to get this outside of that first. That's of the char, that's the void loop. Void setup starts there and ends there. Okay. So let's just put in the startup the pin there. Because in theory, what would happen then? Well, this would set it to all zeros. Alright, well, let me just see if this gives me a value. I would have to actually write it back to memory and then read it back for that to still be valid. Right, 1, 2, 3, A. 1, 2, 3, A. That doesn't make any sense to me, so why didn't that work? Because what I would need to do it this way, so that this would actually change it, so that it doesn't change it back. Is actually just set these all to zeros right here. Like that, and then that would then reset that to all zeros only if they were invalid. To which then this actually isn't needed here, because this would just read it from the memory. Because it's been captured from memory. Password length would be all zeros then. If it's invalid, set the password to all zeros, write that to memory. And this is just... This would what? This would reread it from memory, wouldn't it? Pin length would be equal to those 4 address spaces. I would probably need to reread it from memory though if I did that. Alright, I'm going to comment this out. I think I have an idea of what I'm doing here. Maybe. Only if it's invalid, set the variable to all zeros, and then put that in memory. Otherwise, leave it alone. Alright, so there's our lockout. That works just fine. Button character. We'll look at the part that allows you to check for it to be valid. Because I think that actually might be part of my problem. Hang on, I think I missed the thing I needed to do up here. Yeah, I think I did. Because here's the void setup, right? So I need to get it, which I got it. I checked it. I changed it and rewrote it. Did I load it? I may not have loaded it. I never loaded it into the variable. That's why it didn't work. Okay. So that means this needs to happen after I've gotten it. That's why it didn't work. Because I loaded it from memory right here. And at no point did I ever actually set it to the pin. Now, we still need to make sure it's valid, which is what happens right here. And if it's not valid, then reset it. But now, we can go into our loop. I don't necessarily know why this holds this open. Again, I'm going to look further into that. And then we get the keypad. We check again for whether it's bunk or not, which is fine. And then we go to validate the pin. I think I got it now. I think. We clear the terminal, send the code. Okay, so I took out the print statements. I'm going to access the system. 1, 2, 3A. Access is denied. Okay. And it's not all zeros. Interesting. All right. Jar password, pin length is equal to what we got out of memory. Got it. So I have it right here. So what is not happening down here? If digital read, but pin, and then go to validate pin. She's down here. Ducario the rat, if I'm reading that correctly. Thank you for the follow. I appreciate you sticking around while I'm clearly melting my mind in my terminal here. I'm going to find this because we're basically done. It's almost there. It's just something is not reading this back into memory properly. I know I'm almost there. Almost. And I'm gonna find it. Alright, so here's the validate pin. Serial print line. Enter pin to continue. Print I is equal to 0. Button character is equal to the key press. And then if the password I is not equal to the button character. So we're looking in the index of this and the button character. Okay, so here's what we're gonna do. We're gonna add some write out statements here, so I can have it spit out to the screen what I'm typing and what it's expecting, and we're gonna see why they don't match. So I'm gonna print to the screen. Print. Stored password. And then I'm also going to print on a new line what was typed. And then we're going to see how they're different. Button underscore character. Oh, I missed a semicolon. Right there. Okay. All right, this is gonna help us find it. All right, so I'm going to click pound to enter the system. The stored password is nothing. What was typed was 1, 2, 3, and 4, which is A. Okay, that answers the question. So, what is being pulled out of memory is not valid. It's this square character. So that means the way I pulled it out is not correct. So let's see. We read it from the EEPROM up here. And we stored it in a bunch of addresses. So here's the question. During startup, I declared these 4 inside of startup, which means, or setup rather, not startup. During setup, we can see here that we have the 4 individual values that are going to come back. And then right here, type char prompt put grab... Oops. These were... No, those are put commands. That's right. Further down, we're supposed to be get commands, and I used the get ones. Actually, no, I wouldn't be doing that. I was just getting what we were using. Right, so I did the password, right, the stored password, and then what I typed on the keypad. And inside of password was gobbledygook. Isn't anything usable? So of course it was true that there was a problem because it wasn't legible by the program. When you go to change the pin, Alright, I declared them down here. I'm going to print to the terminal immediately after I set them here if they also look like garbage here. Maybe it's just this line that I'm not doing it right, the way I'm doing it. So here, let's print those immediately after setting them. So I actually want to print a couple things here, actually. After 0, 1, 2, 3, and then I want to print supposedly what is in the 4 addresses of password, because I'm imagining it's probably gobbledygook up here too, by the way I did this, since it seems to be bunk lower in the code. But I want to confirm that it didn't go into the array correctly. Because if I could fix it up here, if that's where the problem is, it'll be fine down bottom, because the logic's all built exactly the way it needs to be. Alright, I'm going to clear the monitor. And then this should spit out what should technically be the same thing twice, but it's probably not going to be. Well, isn't that interesting? I got all zeros. Now, if that means that an invalid character was stored, then it would be all zeros. But it would have been reset down here, not up here. Alright, well, if that's the case, let's try to use the program. Because it did that there. And then here are all zeros. So I should be able to actually hit pound. Enter. Zeros. Okay. So let's see here. This clearly indicated that there was 4 zeros in the memory. That's what I wrote. those memory address locations, and then I pulled out of the 4 different positions of the password, which are again all zeros, which is what we see on the screen. But when it came time to look what was in that stored password, then things broke. So what I want to see now is if this is breaking it. So here's what we're going to do. I'm not going to do this check. I'm going to comment it out. Okay. I think where I tried to comment this, it's not happy with me here. I don't think so, Midnight, only because if it was a typecasting error, it should tell me that the 2 types aren't comparable during the operation. Or at least that's the way I think it's supposed to work. I'm having a tough time commenting this out for some reason. What is this a part of? Oh, I'm commenting that's a part of the 4. Okay. I'm trying to figure out where the heck that is. I just want to comment it out and see if it works. There we go. All right, let's try that. I don't think this is going to fix it, but I want to be sure. All right, so I see all zeros. Nope. Okay, alright, good. So that tells me that this check to make sure the pin's valid isn't breaking it. So I can put that back in. Okay, so if that's not breaking it, what is breaking it? Because I can tell right there that it's being read correctly from memory. And then when being stored as the password, we got our valid options. Wait. This is inside of what? This is inside a void setup. Something tells me this needs to happen. It's not in the right scope. This can't happen here. This has to happen at the upper level because the function that's trying to look at the password, I don't think it can see it. I think this needs to happen outside of this setup function for it to be global and actually be legible by the rest of the program. So we're going to move it. I think that's exactly what's happening here. Which means actually all of this would have to not be down here. It would have to be outside of the initializing. Because everything in regards to this pin has to be global. So let's move it. I don't think it could be down here. I think it's got to be up here. Prom does not name a type. Interesting. So it won't even humor me putting it outside of the setup. Okay. Well, if it's fine there, let's try to check it again once we go into the void loop. Because I'm thinking those values aren't staying global. I think they're getting eaten by the terminal. Yep. Yep, that's exactly what's happening. Yep, and you can see them infinitely looping there. So that's my problem. The pin is not making it into a global state. So now we got to figure out why that variable is not global. We can see here that I can get it out just fine and store it there. It's stored there, printed to the screen, and it's totally fine. Char password and the pin length. You're correct, Pyro. It is a long one. Yeah, it needs to be declared up there. Otherwise, it won't even compile. You heading off to bed, hon? It's like hella late for you. Did at some point I not call it as a char? Maybe that's what my problem is. That's totally fine. Enjoy your sleep, hon. So it's a type char. I wonder if I actually put that down here. Maybe if I don't tell it that it's a char, that's the problem. Nope, won't compile if I do that. Night night. Alright, so I get a ton of invalid characters. But why? And the panic button breaks the code execution for 5 seconds, and then it keeps going. Interesting. Alright, this is the part where I'm going to ask the internet. What the heck am I missing? What am I missing here? The Arduino is assuming you wish to print characters rather than a number. Declare the data array to be a type int rather than char so that you can store the value from analog read. Yeah, well, my example uses chars, and it's defaulting to chars. So what am I doing here? Oh, seriously? It's because I didn't quote it? I don't think this is gonna work. These are variables. Yep, that's what I thought. Okay. Yeah, password passes by. Hmm. And if this was a speed-based thing, that's our pin mode. We begin the serial monitor there. I got the char. And then I was able to print that without a problem. I spot check it using the function. Okay, I'm gonna move this further down my block of write commands to within the loop. Just to see. I'm wondering if speed has something to do with this. The speed at which it's reading the character from the line. Nope, nope. It's still going off at infinity. That doesn't make any sense. Why is it doing that? Oh, I guess I technically would have to stick it inside of one of these options. Which I could. I could wedge these right above here. I just want to see if it makes any difference if I check it a little bit, like outside of that main loop. I was gonna say that should at least stop the endless boxes of doom. Do that, reset the board. Okay, so there's the 4 zeros that are currently in memory, or at least claim to be. And there's my pound, and there's my 4 placeholders, instead of the what should be 4 numbers. I'm gonna be honest with you, chat, I'm kind of stumped. I'm not necessarily sure why the position's no good. I guess here's a follow-up question. I wouldn't think it would matter, but I could always just compare directly against the 4 values that I pulled from memory without trying to restore them into an array, but that genuinely shouldn't matter. Maybe it has something to do with the way I'm passing that along. These chars were declared at this scope, so let's make them global. Let's declare them up here. Okay. It's happy with them up there. And then, now that they're global, I want to wedge them down here and see if I get 4 broken values, or if it gives me something I can work with. So either I'm going to get eight boxes, or I'm going to get 4 boxes and several usable variables. So there's the initial 4. Then we hit pound. Hey! Hey, we're getting somewhere. That's the 4 numbers that were in memory. Those 4 individual characters does mean then the way I loaded the individual char into the block is the problem, because I can actually read the pin directly from the 4 positions. So that narrows down the problem. It's the way that I'm handling it that it's not happy with. So let's do this instead. Let's just pass the values directly into the password. I don't really see any reason to use a middleman here if I don't have to. Because if I do it this way, zero, 1, 2, and 3. And then that would reset EEPROM. That resets it if we need to. And then down here, I'm not playing with those anymore, so I'm just gonna pull those out. Let's push that and see what happens. Then I'm not trying to take individual chars and push them into others. So now I'm going to click pound. And look at that. I got 4 valid zeros. And there's access granted. I fixed it. I fixed it. Now I'm going to lock it. Oh, that took way too long to find. Oh my word. Okay, cool. So now I can actually remove this. And then a little further down here. There's that. And then we can comment these out. I could save it. And now, without a further ado, I'm going to push it, and we're going to unlock it, change it, power cycle it, and see if it holds. So I'm going to use the pound. 4 zeros. Device is unlocked. Green light. Looks good. I'm now then going to do the star symbol. Enter the current pin. Yep. Please enter a new pin. 1, 2, 3, A. Pin successfully changed. Pound. 1, 2, 3, A. It works. Panic. Now comes the important part. All this is working up until the point where I unplug the board. I am now going to show you. I'm going to physically unplug it. Okay, I got bad news. Hi, Aset. Thank you for pointing that out. My mic pack died. The thing that I'm usually talking to stream with, the battery died. So, I can't talk with the bench camera turned on anymore because I'm gonna plug in my mic pack. I've never actually caused this thing to die. So good. I got that plugged in now. All right. Well, I mean, in all fairness, oh my god, this has almost been a 5-hour stream. Okay. That's not particularly good. No, my background music stopped. Let's fix that. I think my music provider has assumed that I keeled over, but I haven't. I have to actually refresh the page. Please stand by. I'm so close to finishing this. I just needed to get it to read it correctly from memory. Interestingly enough, it was all zeros, which I'm not entirely sure what happened there. Alright, that's better. Corby Buff. Thank you for the follow. I appreciate it. I have this is hands down, paws down, straight up, 180%. This is the longest stream I've done so far on this channel. And it's because I did the dumb thing of trying to do a lot of different things in one episode. This is the creative day. Day 15 of the 30 Days Lost in Space. And I've successfully prevented the ability to be able to guess the password. I've added my big panic button to this that I can click, and it resets the keypad. And the last thing was trying to get the pin to be stored in memory and be able to be brought back out again. This part is taking me so unbelievably long. I've never done this before, but that's not going to stop me. Not by a long shot. So, Aset, the captain of all the artists, what have you been up to this evening? You do any fun drawings of the art-like variety? By the way, everyone, Aset is the amazing being that made my emotes. I'm gonna get this. Ha! Got shouted out. Some emotes, yes. Sketching some emotes, heck. oh, Aset, if we may know, whose emotes are you working on? I know that there's a certain Celestial that gets amazing emotes of a fantastic fashion. I love the most recent one you did with like the tail curl. That one was just adorable. Oh, my word. Adorable. Excellent, excellent. Much excellence indeed. She deserves all. They deserve all the love. I'm working on it. Okay. Initially right there. Or technically nothing. It's an empty initialized variable of 4 zeros. Technically speaking. So then the addresses are global, the chars. Technically those aren't needed, but for now they're just going to live there. Zero, 1, 2, and 3. Okay, we got that. Password position 0, 1, 2, and 3. And that's the get from EEPROM. And we're getting them directly out of storage and putting them directly into memory. And then we check, and if they're not valid, then we make them all zeros. I think I'm actually going to add a statement here that writes to the terminal if it changes it. If the pin's reset. And then I'll rerun the code. I'm wondering if it's not reading something correctly here, or maybe my comparison's not good. Suspicious. Oh, well, there's my answer. Look at that. And it didn't only just reset it once. It's resetting it kind of forever here. Okay. Okay, so that means that the way I did the comparison broke. So that just might mean the way I wrote this comparison just might not be good. It might be syntax level of correct, which means it compiles and it runs. But that doesn't mean the logic works. This should only have run once. Or technically, okay, technically it's supposed to run 16 times. But it reset it 16 times. Oh yeah. It reset the pin 16 times. Because it declared that something was invalid, which is exciting. It's okay, Aset. Aset, since you're here, you gotta see it. I can hit the big red button that's on my bench. And then it says panic, system lockdown for 5 seconds. And you can see that right there. It locks up the system and resets the keypad. But this is just a logical error. I mean, I certainly can set it to say that was easy. This is far from it though. Boy. Okay, so my problem is with this statement that I made here. If the password in position 0 is not a valid option. That was easy button. Hey, Set. When you're here in the States, 100%. I'm sure we can find you one. I have a coworker that has a screaming goat on their desk, and if you just push the goat down, it just screams. That's their easy button, essentially. Okay. Right? Okay. For my own sanity's sake, I just want to make sure that what's being read out of memory is actually valid, which it should be, but we're gonna check. Because I'm kind of under the impression that my comparison that I'm doing just isn't right. I didn't write that correctly. Which is fine. It should be easy enough to fix now that I've kind of narrowed down where the problems are. Right. 4 zeros. That's what's in memory, which makes sense because it says right here that it reset it to all zeros and then wrote that to memory. So, all right, well, that was technically kind of a poor example. I'm still going to leave it in there for now. Because it was fine until I restarted it, and then from memory, it still reset. Now, here's the other thing, too. Even if these were invalid, right? Which they're not, it read zeros. That's what it pulled out of memory, was 4 zeros. And we know that 0 is one of the options. No. It is? Yeah, wait, it's right there. I was gonna say, tell me I forgot a valid option. Of course, I can see myself doing that. All right, that's a char, and that's a char. And something makes me think they're not being compared as chars. I wonder if I do this. Expected the closing brace before char. No, because I'm not declaring it in this scope, so I don't need that. All right, well, I know the easiest solution would be to comment this out, which would solve my problems. But in the event the memory were to get corrupted on the Arduino, that leaves you with a hole that cannot be patched automatically by the code, which is why I'm trying to do this. I suppose instead of one long if statement, I could break this into smaller ones and try it that way. Let me make sure I also did this right too, because I don't think it'll take it if I do it that way. It should bark at me. Wait, I think I had that backwards. I think I had that backwards. No, exclamation mark equals. I had that right. I'm fascinated that that compiles, actually. I didn't think it would take that. Huh. Okay. I don't think it should have, but it did. Well, since this is technically 2 arrays now, so let me try to change this up a bit. I'm gonna put that for loop back in that I pulled out. Let's see what I use to validate the pin. Because maybe just the way I'm going about this just isn't really right. Alright, so for int I, you are correct. I've run out of tea, but that's okay. I have my water bottle. Okay. So here's what we're going to do instead. We're going to cycle through this. For int I is 0. We're going to run this 4 times. And then inside, we're going to run through every possible option from the keypad, which is a total of 16. Okay. Let me save that. Let me send that. Nope. It still did the same thing. Obviously zeros are valid, and it reset it 16 times. So this is still not the right way to look at this. All right. Let's see if I can find the right way to look through a list of chars. Yeah, finding a specific char in an array. Let's see if we could do that. Nice. Length. Size T. All right, let's see if this works. If strchr these functions do not work with wide or multi-byte characters. Return the string function returns a pointer to the matched character or \c null if the character is not found. But we're purposely gonna look for the character. So we're gonna say password. We're gonna look for index I. I think I might have. I think I might have did this backwards. No, and then what I'm looking for. I think. Yeah, I am doing this backwards. I would want to look in the list of valid options. Other way around. Valid options. I actually don't need the... Yeah, I don't need that. Do I need that? I don't think I need that. Do you know what that is? You do know what that is. Alright, good. Yeah, so within the valid options, I'm looking to see if my password character is in there. Alright. This is 100% very experimental. So, for a moment, I am going to comment out this other stuff I have here. Because I now realize that the only way I'm going to see if this works is if I dump it to the screen. So what we're going to do is we're going to do a print serial print line. We're going to see if that does anything. Oh, that's right, because that's okay. Yeah, I have to hard code it because I'm not in the loop anymore. Okay. Alright, and it returned the pound symbol in D. And it was a 0. Well, there's pound D. I'm a little confused by what this function does. Returns a pointer to the first occurrence of the character val in the string. Here character means byte. These functions do not work with wide or multi-byte characters. Return a pointer to matched character or null if the character is not found. To not confuse myself, I'm going to comment these back out again. Alright, so it returned 0 pound D. What if I give it position number 1? Which would be the second 0, which actually is probably going to be the same thing now that I said that out loud. Yep, it is. Alright, well. I'm all kinds of confused as to why that doesn't seem to work. But I think for now, as long as I can get it to store valid information and not eat it, I think we're going to consider that good enough. Let me send it, let's test it, see if it works. There. So I'm going to do pound. There's 4 zeros. Star. 1, 2, 3. Oh, wait a minute. Wait and continue. And then new pin. Alright, now it's 1 through A. And then okay, I can reset. And then now I'm going to pull power from the board, reset it, and see if it reads the memory back. Okay, you guys saw the terminal. That little yellow bar indicates I unplugged the board. Now, we're gonna try it again. See what happens here. Pound, 4 zeros, should fail. It failed. Now, I'm gonna put in the pin I set. 2, 3, A. It works. It actually works. I'm gonna hit the big red button. I have reset it. Much excellence. I'm not entirely sure. I think I just pushed it a little too far. I think trying to figure out how to compare one char from a list of chars is something I probably should have did independent instead of trying to do it live. I truly believe that's something that could be added to this. But with nothing in memory, technically speaking, this won't let you in, right? Because I'm looking at this. There is a hole here because there's no initial pin at this point. So, short of programming something into the board first to be as your initial pin, there wouldn't be anything to necessarily let you in from the absolute start. So I'm sure that that's something that can be figured out, but I have exasperated my my thought process on it. I'm not going to delete any of it. It's just going to live in the code for now. And yeah, at some point I might revisit it, but for right now I think I'm done. That's a lot. I've been here for 5 hours. I'm good. I'm good. This is one of those things. I have reached my stopping point. So let me see who is available in the list of good beans. Let's see where we're gonna wander off to. Because to be honest with you, this is much later than I'm normally going, so I don't know who's on right now. Let me see who is available. Oh wow, there are lots of beans on right now. Pyrex, thank you for sticking around. I appreciate it. It's been a very mind-melting kind of evening. As I say that, as it's almost tomorrow. This was a long one. Okay, I found where we are going to wander off to. Flybyfox is someone who has been kind of on and off with streaming. Just recently kind of got more back into it. A very family-friendly streamer. So we are going to go wander off and say hello to the lovely Flybyfox. As for our raid out message, lights in. I got this. I could be fast enough. We bring lights and confusion for the raid message if anybody wants to play along. I thank you all for sticking it out with me. I appreciate all the raids I got today. It's super awesome. Thank you for those that stuck around. It was very much appreciated. This is a very mind-melting activity. My streaming schedule is Wednesdays, and I start around 6:30 Eastern time. This upcoming Wednesday, I will be unavailable, so I will be back the Wednesday after. So with that, have a lovely time zone, everyone. Bye-bye.